Gauteng, grade 12, 2020, prelim paper 1 memo. You know what it do, I was about to embarrass myself. But anyways, this is the prelim 2020 paper 1 Gauteng paper. We're obviously going to go through the entire memo. And I am not going to waste your time, especially with these simple things. So let us just fly through them. So we know that here they want us to solve for x, right? And they said we should leave our answers to 2 decimal places. So, I mean, questions like this, they basically want you to just use the quadratic formula like 99% of the time. And like all the time, really. So here, we know that we can take everything to one side. What is going on here? Yo, 6. No, man. Come on, make it bigger. Let's see. So it's like someone suggested that I should not change colors when I like do these questions. They said it might make me like write faster, or they said it might make the video shorter. And I was like, what? I don't know about that, but it is what it is. But yeah, I really don't think changing colors is a big issue. But anyways, B here is a 5, so we know that this is 5. And let's see here, 5 squared minus 4ac. The whole thing over 2a, of which our a value is just a 3 over there. So the issue is, well, there's no issue here, to be honest. I mean, like, let us be honest. There's really 100% no issue here. But the only issue is that I didn't put these values here. Like, bro, what is going on? Please wake up. Yeah, so obviously, yeah, if you do spot any funny errors, as a belief, please let me know. My RG handle is this one over here. You see, you can just hit me up and be like, hey, yo, you wrote this, but it's supposed to be like that. Yada, yada, you know the drill. You know how it is. But anyways, this in your calculator should give you x as 0.91 or x as, let's see here, negative 2.57. Nothing crazy here, nothing major. 1.1.2, we know that it is almost like a similar scenario. You see, my opinion is that with stuff like this, just mind your steps, you see, and mind your signs. Like here, if you put everything on one side, we can clearly see that if you put this into the quadratic formula. Now, I know that you may be wondering, do you always have to write down the quadratic formula before you use it? I mean, it's really not going to cost you anything, so you might as well do it, because sometimes you might get like an examiner that is not in a good mood, and then that's the sad thing about marking papers, because it's like they're marked by human beings, but then I'm not trying to say that their emotions affect your marks or anything. No, you see, I'm just trying to say, hey, yeah, we should just don't leave anything to chance. So here, putting everything into the quadratic formula, let me see here. It doesn't look like there's any issues here. You're going to get x as a negative half, or you're going to get x as a positive 5. You see? So these easy ones here. Don't waste your time. You see, don't waste your time. So with something like this, solving this inequality, the one thing I recommend is always put your equation into standard form. You see, always take everything to one side. And the one thing you want to recognize is that this is just an equation of a parabola. So this is literally a scenario where you're dealing with a parabola that's smiling. So what you want to do is you want to draw a smiling parabola for yourself. And then you basically want to find out if this equation has any x-intercept. So because this is basically asking, where is this graph above 0? So if you're going to work out where it's above 0, you firstly have to work out where it's actually equal to 0. I mean, like, so because you working out where it's equal to 0, you're going to use that as like some kind of reference. So I mean, here I'm really not gonna write down the quadratic formula, because I'm like, it's just so taxing, and I feel like I'm going against my own words here. But then in this situation, I mean, the main task is not to necessarily solve for x. Okay, well, technically you are solving for x, but then this is more like, it's within the method. So yeah, I feel like I have no I'm just I legit ran out of things to say so early in the game. Makangi, come on, man. So Here you're going to get x is equal to 4, or you're going to get x is equal to positive 1. Now the idea is, what that does is it gives you roots, or it gives you x-intercepts, because this is the blue line is your x-axis, right? So this over here is going to be obviously towards the left. This is like positive 1. Towards the right, that's like a 4, you see. So now you can easily answer your question. The question is asking, where is this graph above 0? Now you know that it is above the 0 over here. You see, this is the part where it's above 0, and this is the part where it's above 0. Now this part that it's above 0, you can already see that you get this portion of the graph if you're talking about x values to the left of 1, and if you're talking about x values to the right of positive 4. So obviously your answers need to say that x needs to be smaller than 1, or x needs to be bigger than 4. You see, this is how you can put your answer. Now another way you could have written it is, obviously you could have said x is an element of negative infinity. Yeah, that's looking at 8, bro. Negative infinity. This infinity symbol doesn't want to be drawn, this one. Yeah, negative infinity all the way to 1, or x is an element of what you may call 4 all the way to positive infinity. So you can write it out like this, or you can write it out like what you have there in red. It is purely a choice, you see. So I'm going to erase this so that on the PDF it doesn't look like there are many ways or whatever, you see. But I think let me actually just color code this into a different color. What you got, change style. Danko, I'm assuming you're probably listening to this at like ×2 speed. How do I sound, How do I sound at ×2 speed? If I'm not at ×2 speed, you're brave, You're brave, but it's all good. It is all good. We ain't gonna hate. No, wait, that's not hating at all, actually. But anyways, for 6 marks here, I feel like this is the first real question. This kind of a question, the one thing I can safely say is, for a question like this one, you need to think outside the box, but not too far outside the box, because here, this is technically to the power of 1, right? And then here you have something to the power of a half. Now with questions like these, okay, you could take the 4 over to the other side, and then this is what you have. So with questions like these, in terms of you thinking outside the box, right, we're just going to show like a trick that you can use to answer these kinds of questions. So here, this x to the power of 1 and this x to the power of a half, you want to write these in a way that allows us to like use the K method. So this is, you want to put this in quadratic format, you see. And the only way you can put this in quadratic format is if you make use of this here. This should be your hint, you see. So what I mean is this, you can write it as x to the power of a half as well. But then this here, you can actually square it, you see. And then the rest of your equation stays exactly the same. So the reason for you doing what we have done here is so that you end up with a quadratic equation where we basically have this thing here as your variable, you see. Because remember, the quadratic equation, it's all about the format, you know. The format is in quadratic format, you see. Yo, does that even make sense? Yeah, look, you see, this is a squared, and then there's a b here. No, oh goodness, bro, you're embarrassing yourself here. The a value here is a 1, right? But then here there's something here squared, and then the b value here is technically a 3, and then there's like something here squared. No, not squared. And then here minus plus c equal to 0. Okay, let us clean this up, because it's like, hey, what is going on, What is going on? Let me actually replace x here with a k so that it's like easier to explain. You see, there's like a k here, you can see it's squared. There's like a k here, it's not squared. So obviously this is telling you that whatever this is, it represents whatever this is. And you see, this here is something that you can solve using the quadratic formula. You see, using the quadratic formula, you already know that x to the power of a half is equal to minus b plus minus b squared minus 4ac over 2a. You see, you know that because, how do you know that? Well, because of this variable, you see, this variable over here is squared, this one here is not squared. But then, yeah, I think you get the idea. I really think you get the idea. And remember, feel free to just DM me anytime on IG. with a screenshot of anything that you need me to, like, re-say, and then I will send the voice note so that you can understand. But obviously the comments are there. You can always throw your question in the comments, and I'm like, if you look nicely in the comments of like other videos, you will spot that I respond to all the comments, because I still have the liberty of doing that. Like, how fantastic. Anyways, I should just speak normally now, like, really. Anyways, so here, if you're gonna throw everything into your formula, let's see what you're gonna get here. B is technically a -3, so this is like -3. I should zoom in nicely here so that I don't run out of space, because I really see myself running out of space. Yep, this boy is gonna run out of space, so ish. Oops, excuse me. Yeah, I don't know what to do now. This boy is running out of space. This boy is running out of space. Running out of space. So early. And I'm busy wasting time singing. Anyways, that's B plus minus B squared minus 4A. What is A? A is like a 1. You see, the number in front here is like a 1. And then C here is like -4. And then the whole thing, oh my goodness, the whole thing here, A is like a 1 over there, dango. So this here, you need to make sure that it's going to be equal to x to the power of a half. You see, just be careful. Just be very careful, okay? If you can just be very careful, you will be good. So if you put all this into the calculator, let us see what you're getting over there. So you may be thinking to yourself, is there not like an easier way to have done this? I mean, like, there definitely is. There definitely is. Like, to be honest, there definitely is, eh? Like, you could have taken this to the other side and then brought the 4 over, and then you could have squared both sides, yada, yada, yada. But I guess this showcases, different ways that this question can be tackled. So yeah, let me actually put all this into the calculator, because I just realized that I'm busy talking, but I'm not actually putting stuff into the calculator. So excuse-moi, let me just put this into the calculator. This is going to give you a 4, or what is it going to give you? It's going to give you a -1. So the idea is, for the -1, this is not going to give us any solution. So we have to, like, showcase that. So for this one here, x to the power of a half, the lucky thing is here you can just put a square root symbol with like a tiny half there. Square root symbol with like a tiny half there. It is like 1000% valid. You are welcome to do that. So here you're going to get x is equal to technically what? Boso. What is going on? I think x is going to be equal to x is going to be equal to like 16 in your calculator, because in your calculator you're just going to say shift with the square root symbol and then replace the 3 with the half and then put a 4 there. You're getting 16. So verbally, here this is going to give you no solution in your calculator, you see. So this is your only answer. Now verbally, what I can safely say is, obviously, for this kind of a question, another way that you could have looked at it is something like this. This, you can take it over to the other side. This, you can bring it over. You could have had x minus 4 here, and then this would have been equal to like 3 to the power of x, like that. And then, actually, let me make this smaller, man. I'm busy writing something that's too thick. And then from here, you could have just squared both sides. So let's say here, square both sides, you see. And then you could have carried on. You would still end up with this answer. So yeah, there we go. Here it says, show that the equation this only has one solution. Well, how many marks? It's out of 4. So I mean, an equation like this, you obviously do want to simplify first. Now something like this tells us that the basis can be, what can happen with the basis? You can give the exponent two bases, because you see your bases were the same, so you added them. And then here dot to the power of x minus 4 equal to r0. Hey, what's going on here? Well, technically, since we're trying to solve for, it says show that this equation has one solution. So technically we're just solving for x, you know. So it looks like yeah, this is also one of those equations. Yeah, this looks like we definitely have to use the k method here, because if you look at it nicely, right, there's 2 to the power of 2x here, and then 2 to the power of x. So this here can technically be written as this squared with like a 2 there. And then the reason for doing that is so that we can identify that 2 to the power of x is something that is like, you know, showing up multiple times in our expression. So the big idea here is, yeah, you're gonna need to say let k equal to 2 to the power of x. So using this method allows you to identify a quadratic equation, because you see this 2 here, you can write it in front there, and then the 7 is just there, 7k, and then minus 4 equal to 0. So that now you can just solve for k and then carry on later, you know, carry on later. Phew, why didn't I just give myself gang space all the time? But don't worry, né? Like towards the end you'll see I gave myself so much space on the right. But let's see here. Obviously this you can work it out using the quadratic formula. So here you can say k is equal to minus b. Yeah, net the amount of times I've written out this formula. Hey, yeah, me. You can imagine, man. You can imagine. It's just like so crazy. Like, oh my goodness. Like, oh my goodness. So obviously, as you're looking at this, my assumption is that you've maybe like gone through the paper at least, and then you're basically hopping and skipping to the specific questions that you need clarity on, because there's really no need to like go through everything, you know, like especially if you've gotten it right and everything. So here b is just, what is b? B is a 7 plus or minus 7 squared minus 4ac. Hey, come on, bro, you must put values into the thing, man. You must put values into the thing. Hey, what kind? Yes, like I should get some Capetonian friends, yeah, that can teach me the lingo there. Let's see, a is a 2 over there. All this into the calculator. I wonder what it is that we will get. So all this into the calculator, it looks as though we are getting k. So this is like k, right? So here it's gonna be k is equal to a half, or k is equal to, what is k now? Or k is equal to -4, you see. So that's for k. So what you can then do is, therefore, you see, you drop k in there now. So here it's a half is equal to 2 to the power of x, or 4, or -4 rather, is equal to 2 to the power of x. So here there's nothing that you can do here. You see, here you'll end up with something like -2 to the power of 2 is equal to 2 to the power of x, of which here there's no solution. You see, it just bombs out this one, because obviously these can never be the same. You cannot throw any value of x here that will give you a negative value here. So here now this one is easier, because I mean you can just use logs if you want, but then the issue here is, you see, you can either use logs, or what's the easiest way to do this? Well, the easiest way, I mean, like we're not, you're in grade 12 anyway, so this is an exponent. If you want to isolate an exponent, you isolate it, and then you say log whatever the base of the exponent was, you make that the base of the log, and then this half is just here, and then you put all this into your calculator. Your calculator is going to give you a negative 1. Yes, that is what it is going to do, because this base here becomes the base of the log. This number here is just that number. So nothing crazy, nothing major. It's all good, eh? It's just vibes all the way. So solving for x and y simultaneously here for 6 more marks. Yeah, this one looks like it's set for us so nicely, eh? But then the one thing I can safely say is this looks like it's gonna cause problems, this square root symbol here. So what you may want to do is, before you throw this value of y in here, just simplify this expression. Like, you know, the said stuff, third, I mean, these things here, they're not very nice. So obviously with this here, with the square root, it looks as though the best thing you can do for yourself is to just square both sides first. Because why not? You know, why not? I feel like I say that so often that I feel like one day someone is going to be like, because blah, 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 blah. And then I'm just going to be like, okay. Yeah, I think you know, I legit have the feeling that I'm legit on like 2 times speed right now. Like legit, bad. But anyways, let's go. What is this now? Ish, it's almost like all those times when you listen to like a WhatsApp VN on times 2 speed. Even if someone is saying something serious, just because it's on time 2 speed. It's like they're just making jokes. But anyways, y times y, this is like y squared, this and that, negative 3y, positive 9. And I remember one day someone was like, bro, you're going too fast. And then I was like, ish, yeah. I didn't know. I forgot what I said there, to be honest. But yeah, I think in on YouTube you can like slow down the video, so others will speed it up to 2, but then feel free to bring it to like half the speed if there's a portion that's like, you know. Yeah, so let's take everything. But you may be asking yourself, okay, fine, when do we then just take this and throw it into the expression? I think at this point in time we can do that here, because we were just trying to simplify our expression, just so that at least, you know, when we then start to throw in other things, it's not too messy. That's basically the idea behind what we were doing, you see. So now that we have done what it is that we have done, let me see here. I'll remove over the what are you saying, bro? Yeah, there we go. So let's see here now. So arrows. Yeah, I'm an arrows person. I'm like arrows person. So with everything that we've done here, we can then definitely say this is equation 2, this is equation 1. So we're gonna say equation 1 goes into equation 2. You know, my circle does not want to be drawn. What is this now? Yeah. So equation 1, if you throw it into equation 2, you're going to have 2 minus this whole thing here, which is y minus 13. And then this is equal to like y squared minus 6y plus 9. You see, that's the way. I like it. Whew, let's see. So this is like 2 minus y plus 13 equals to like y squared. Why are you narrating? Why can you not just write? So if you take everything to one side here, let's have 0 there. Y squared. Negative 6 plus y is going to give you a negative 5. And then these two, they are going to give you 15, you see. So when you take it to the other side, it's going to be 9 minus 15. Eish, what is 9 minus 15? I want to use the calculator so bad, because my mental math, it just doesn't want to mask and work, you know. It just doesn't want. So 9 minus 15 is like negative 6. So yep, negative 6. And then here we can say y is equal to minus b plus minus blah, 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 blah. So to be honest, I definitely do feel like there are cases where rewriting the quadratic formula, it's really not necessary. Especially with such a long question like this. Like you can imagine, man, like yo. But I mean, at your own discretion, do what you want or do what you feel is best. In my opinion, there are cases where I can safely say it's really not necessary. Like, hello. So here, if you throw everything into your calculator, we're gonna get 2 answers here. What are we gonna get? Let me just double check something here. Yo. Oh, this is scary. Negative 5 and negative 6. Ish. Hey. Let's just get. I'm getting here. Y is equal to 6 or y is equal to negative 1. So with these 2 answers, obviously we should be getting 2 x values. So if you get an x value over there, x is going to be equal to 6 minus 13, which is just x is equal to what? Negative 7? Or x is equal to negative 1 minus 13. This is x is equal to negative 14. But the issue with these kinds of questions is anytime you see there's a surd always test your answers. Always test your answers if you see there's a surd, because surds, they just ruin things. So if you test your answers right, you'll see that the 6 and the -7, they balance out, you know, if you throw them into your equations. But then the -1 and the -14 don't balance out, because -14, if you throw it there, it's going to be like 2 plus 14, right, which is 16. And then square root of 16 is a 4. And then for the y, you would have thrown in there a -1, you see, of which -1 minus 1, no, -1 minus 3, that's a -4. So the sides don't balance if you use -1 here and if you use this. So these ones, you have to disregard them, unfortunately. And we said we're disregarding them because they don't balance the equation. So look out for cases like that, because if you don't look out for cases like that, you will regret it. But anyways, let me plug the brand over here. So this is like the course platform where you'll find like different courses, etc. On the course platform. Well, the tab that I'm currently working on is currently in airplane mode, so I cannot wait. Anyways, and this is my IG page. You can always DM me if you have questions and stuff like that. So obviously, if you're gonna DM questions, just make sure that you've at least tried them out, you know, and you've looked at the memo and all that shandies. But anyways, let us move on to question number 2. Okay, Gauteng. What are we doing in Gauteng? We're doing the prelim paper for Gauteng, the smallest province in the country, but the one that is always popping, you know, facts. But anyways, question 2 says here, given the following quadratic sequence. Okay, write down the value of x in the sequence for 1 mark. Wow, hey, they're answering us here, but it's fine, it's fine. Free marks, free marks. If you see a question like this, just don't even complain like what I was doing. I don't even know I'm complaining about free marks. Like what do I expect? Why do I always want things to be difficult? Okay, no, that's not true. I'm super glad that this is like super doable and stuff. So you wanna check for like the sequence of first differences, and then you wanna get the sequence of second differences, or the second common difference, right? So 7 minus 1 here is like a 6. 15 minus 7, what you get there? What is 15 minus 7? Isn't that like an 8? Is it 8? I hope so. 25 minus 15, that's like 10. So x minus 25 is what's gonna go here. And then obviously if you check again, this is 2, yeah, you see, this minus that is a 2, this minus that is a 2, this minus that is also supposed to give you a 2, you see. That is the way. I like it. So everything here is equal to each other. So you can just solve for x that way, you see. 2 is equal to x minus 25 minus 10. And then everything here, this is like -35, right? So if you take it over, it's going to be like 2 plus 35. This is equal to x, and then this is like 37. Fantastic, man. Like, we love to see it. Nothing crazy about that question. The next one. What does the next one say? It says determine the expression for the nth term of the sequence. So determining an expression for the nth term of a quadratic number sequence, this is all you have to do. All you need is this. You see, obviously you need this structure. If you don't have this structure, yeah, you know, you're just going to be doing yourself a disservice, you know. So as long as you have this format here, always remember that the very last number here, you always equate it to 2a, always. The first value here, you always equate it to 3a plus b. And then your first term, you always equate it to a plus b plus c. And it has to be this, and that, you see. Because you're basically trying to get your general term. The general term of any quadratic sequence looks like this, because it's purely just a quadratic number pattern. Okay, fantastic. We're gonna get A, B, and then C in that order, because we're going to start from the bottom and end up with the answer. So starting from the bottom, we're gonna have 2a is equal to 2, which is gonna give you a as a 1. You see, if you divide 2 on both sides. And then here where a is, you're gonna throw a 1 there. And then solving for b, you're obviously going to have a 3 because this 3 is going to go to the other side. You see? Progress, Papa. We're moving. We're moving. A is a 1 over there. B here is a positive 3. C here is what we're looking for. So this is like equal to positive 1, you see. And then here C is going to be equal to 1 minus 4. That's like a 3 because this 4 here goes to the other side. Oh, no. I made a mistake. It's a minus. You see, the moment I started talking about the rushing, I started already making like dumb mistakes. So I was like, this ninja, like, what is it doing? What is this dude doing? Anyways, if you throw everything into your calculator, if you throw everything into your formula, you're going to have here, therefore, Tn is equal to n squared because a is a 1, and then plus 3n minus 3. So the way we go through these papers, right, from start to finish, this should give you the idea that in an exam, this is why they expect you to finish a full paper in a space of 3 hours, because you should just be like, what you may call, you should be solving the questions. You shouldn't be thinking about what to do. You should just be executing, you see. That's basically what I wanted to say. Okay, 2.1.3. Here we are go. So with 2.1.3, it says here, Wn represents the general term of a sequence for the first differences. And then it says here, determine the value of the nth term of the quadratic sequence if Wn is equal to 50. So what they mean is, if you look nicely, let us look nicely here. Let's take this thing here. I feel like we need to use it again. Copy over here. So let me paste it over here. I might as well put in a value for x already, because I mean, like, x is 30 what? 37. So this part over here is just like a 12. Mathematics, Baba. This is a 12. And then obviously the second common difference here is just a 2. Fantastic. So they said Wn represents the general term of a sequence for the first differences. So what they mean is, in your sequence of first differences, this one here, 6, 8, 10, 12, going on and on and on. Somewhere along the lines, you have the number 50. So the number 50, whatever it is, they say it here, determine, I jumped the gun, bro. What are you doing? Let's erase the 50. I'd already jumped the gun, but let me repeat. Wn here represents the general term for a sequence for the first differences. So whatever Wn is, it is the general term for this sequence here, 6, 8, 10, 12, going on and on. And then it says determine the nth term of the quadratic sequence if W50 or if Wn is equal to 50. So what they mean is, in this sequence, right, somewhere along the lines, you're going to have a value that is equal to 50. So you don't know which position this is at, you see. But then whatever this position is at, you need to find the position of this value and then throw that value into your quadratic number pattern. Let me repeat. The nth term of your quadratic number pattern, right, it is just, what did we get here? The nth term of our quadratic number pattern, it is just Tn is equal to n squared plus 3n minus 3. We have gotten the quadratic number pattern formula. We have it here. They say it here, the general term of a sequence for the first differences is represented by Wn. So our sequence of first differences, we know that it is always an arithmetic sequence. You see, it's always an arithmetic sequence. So this thing here, we know that it is just an arithmetic sequence. Let's put here arithmetic sequence. You see, it's an arithmetic sequence. So this being an arithmetic sequence, it obviously has a general term of Tn is equal to a plus n minus 1d. So they said here we should determine the value of the nth term of the quadratic sequence if Wn is equal to 50. So we just have to find out what Wn is equal to 50 produces. Or what I mean is, in your formula, right, Wn is equal to 50 means that whatever this is, you're going to make it a 50. and then you're basically going to get an outcome from this, right? Let's actually even put Wn here so that it all matches with whatever it is that we're doing. Wn is equal to 50. So what they're basically trying to say is, if you take Wn as 50 and solve your equation, right? Obviously here you're going to get the position of the 50. Whatever the position of the 50 is, you're going to throw that number into your quadratic number pattern over here. That's the answer they're looking for. So if you look at the question, they say determine the value of the nth term of the quadratic sequence if Wn is equal to 50. So we know that us solving for n here, so that we can throw that n into this equation, we know that a in our sequence is just a 6 over there, and then the common difference, it is clearly just a 2 over there. So this is just a 2. And then here you just want to simplify until you have solved for n. So let's simplify here. This is more like 6. 2 times n is like 2n. 2 times -1 is like -2. And then solving for n here, you just have to be careful. You see 50 here. 6 minus the 2 is like a 4. So when you take the 4 over, it becomes a negative. And then here you're going to have like 46 is equal to 2n. N is going to be equal to 23. Oh, 3, bro. Why are you putting a 6 there? N is equal to 23, you see. So as soon as you've gotten n is equal to 23, now you can use your quadratic number pattern, because your quadratic number pattern, I mean, remember, we might as well even read the question. We don't have to read the question again, because I think you get it now. But then the big idea here is, obviously, if this was not clicking, then yeah, you just need to read the question. What am I saying? How can you just say that? Sounds so rude, bro. Come on, like what the hell? But what I mean is, yeah, anytime they speak of like the nth term, right? They're talking about the formula of whatever they're talking about. Anytime they speak of general term, they're also speaking about the formula. So it says here Wn represents the formula of a sequence for the first differences, right? Then it says determine the value of the nth term of the quadratic sequence if Wn is equal to 50. So in this case here, we have to work out what n is if your term here is equal to 50. The moment we get this n, we just have to throw it in there. So the n that we got here was 23. So we're going to put 23 over here squared. And then, bro, you have so much space, but, oh, no, I don't actually. Wait, it can actually fit. It can fit. It fitted. Bro, does that even make any sense? Did you just say it fitted it? Yeah, English is not our mother tongue, eh? I botched it so good. But anyways, this is like 595 over there. You see, nothing crazy, nothing major. So, I mean, to get a better understanding of like quadratic number patterns and like how to break down your words and your keywords and your questions, you can always check out the course platform. You see, the course platform it will sort you out good. Let me see if this is clickable. Nope, it's not clickable. But anyways, at any point in time, you can always just go on Uncle Google, and then what you want to search here, you want to search Bright Young Brains. Let's see what happens if I search Bright Young Brains here. Bright Young Brains. Oh my gosh, look at that. And then if you scroll down, oh, look at that, reviews. Nice. I mean, if Bright Young Brains has been useful, please go and give us a review on the Google. That will be very much appreciated. Like for real though, like if Bright Young Brains is like helpful, please give us a review. But anyways, yes, so for the courses name, you can already see here the first result is like Bright Young Brains over there. So if I click on Bright Young Brains over here, it is going to take me to like the course platform. So obviously, as of this recording, this is the course platform. Yeah, this is what it looks like. There's the all access pass, which gives you access to like all the courses on the course platform. But then you also have the liberty of like purchasing the courses individually. But I don't think that's a good idea. For example, you see, you can have Euclidean on its own, trigonometry on its own. But then I feel like the all access pass is your best bet, because this one gives you access to everything for like one fee. And this is something you can cancel at any time, obviously. These are like the recordings of like the one-on-one Zoom sessions that I conduct. So this one is always getting updated. I'm sure by the time you go to the course platform, there's like way more than 40 lessons here. And then, there's like the NBT course. I'm still currently working on the NBT course, because the target is like 300 examples. And then in this NBT course, you obviously have like a full past paper. You see, like a full past, the paper that I wrote, which is like here. Where is it? The actual NBT that I wrote. Yep. It is right over here. All the questions, it's like 54 questions that I managed to get. Even though the test is like out of 60, I managed to get to write down 54 of them. And as of this recording, I still don't know what I got, because I need to like shoot a video of that. So it's going to be like a reaction video. So I'm only going to find out my marks when I actually, am able to like record it and stuff. But I think this is more like a hack, because if you get the all access pass, you already get access to the NBT course, of which the NBT course, you can see it's like a premium product. But enough with the plugs. Where am I going now? I need to go back to the course. I need to go back to this. Okay, anyways, let us carry on, right? It says determine the sum of the first 500 terms of this sequence. So, I mean, you want to look at the way this is structured. It started here with like 2.1 and then 2.1 yada 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 yada. So if they're talking about you getting the sum of the first 500 terms of this sequence, you may be thinking to yourself, but then which sequence are they talking about? Are they talking about I jumped the gun. Oops. Yammer. I was so confused myself. I was like, what? How do they want us to do that? So the reason why this did not make sense is because for a quadratic number pattern, you don't necessarily have like a formula to work out so many of the terms at once, because normally with the quadratic number pattern, you need to add them up manually and stuff. But here I can clearly say I'd left out this question. I don't know why. Maybe my head was somewhere else. Where was your head, bro? It says you consider the following. This is what you have, ne? So what you want to recognize with what you're looking at here, this is just two sequences in one. You see, you have a sequence of zeros. You see, 0, 0, 0, 0, 0. You even almost want to disregard the zeros, because they are kind of useless. Like, what the hell, man? But then your sequence here, you want to focus more on like the fractions, you see. So they say it here, assume that the pattern continues consistently. Write down the value of the 191st term of this sequence. So this question what am I saying, bro? Did you just say? Yeah, this question that was embarrassing. No, it was not. I hardly get embarrassed. That was just weird. This question looks like, I think this is one of the questions in the sequences and series course. Like, I kid you not. But anyways, the easiest thing to do for yourself here is you want to look at the zeros here. You see 0 is in position 1. It's in position 3. It's in position 4. No, bro. This is position 5. Position 5, 7, 9, 11, going on and on and on. So obviously you can imagine at position 191, this you can see these are like the odd numbers. Odd number. So obviously 0 is going to be in that position. You see, so here T191 is just going to be a 0. They'll give you 1 mark for that. You see, nothing crazy, nothing major. The next portion, they said we should determine the sum of the first 500 terms. So even though they're asking for the sum of the first 500 terms, you want to recognize that, I mean, the one thing that makes sense is to just deal with your fractions, you see. If you're just dealing with your fractions, you actually just need to work out the sum of the first 250 terms. You see, because the other 250, they're just zeros. You see, so if they're asking for the sum of the first 500 terms, technically you can just work with your fractions and then get the sum of the first 250 terms, because the other 250, it's just zeros, it's just zeros. So let me see here. This is just negative a half. You have a half. You have 3/2. You have 5/7, going on and on and on. Yeah, this is definitely one of the questions in the sequences and series course. Like, I kid you not, like legit. I'm so tempted to like show you, but I feel like you trust me, so I don't have to like prove it, because I'm definitely serious. This is one of the questions in the courses, because remember, in the course there's like it's a mixture of questions, mixture of like, you know, ways of tackling different questions. So the courses are really helpful, so I suggest you sign yourself up if mathematics is not your friend. You see, anyways, it says here we need the sum of the first 500, the first 250. So here I'm trying to identify what kind of a sequence this is, and from the looks of things, it looks like it's an arithmetic sequence, because it looks like we're just adding one all the time. So here, the sum of the first 250, we know it is just n over 2. Let me just put Sn over here first, and then write the sequence. Sn, we know it is equal to, how's the formula? Sn, and then 2 here. This formula is on your formula sheet, so you obviously don't have to cram anything, like, hello. So here, the sum of the first 250, this is just like 250 over 2. A is like negative a half, and then n, what is n now? N is like a 1. 1 minus 1. Oopsie. And then difference, no, n is 250, bro. I have mixed up the n and the d. I was like, how is this giving us n minus whatever now? I was like so confused, even me. Negative that. So d here is just a 1. So all this, you basically just want to put it in your calculator, really. You see, you basically just want to put it into your calculator, because, I mean, why not? I mean, like, while you're putting all this into your calculator, I think you can take a screenshot or a picture on your phone. I'm so tempted. I can't help myself. I just want to show you that if you go to the course platform, this is exactly what you get. No, wait, let me show you something on the course platform. Where's the course platform here? Let's go here. If I go to NBT, I'm not supposed to be here. I'm supposed to be, where's the other one now? Here. You see, this is where I'm supposed to be, here. And then no, let me actually go here, because here I can access the course platform immediately. So on the course platform name, if I go to like the where do I need to go? Oh, I need to sign in first. Come on, bro. Hey, it's too much work. Never mind. We will talk about it later. Let me actually just maybe pause. Okay, so I just subbed in my details. Let me put even remember me here. So let me just sign into the course platform. So if I sign into the course platform, basically, what am I doing here? Okay, if I click on all courses here, wait, no, I should actually go. Where should I go? I should go onto my dashboard. You see, my dashboard. This is just like a what you call a random profile that I created for myself. So there's nothing, that's why all this is just zeros, you see, because it's just like a random profile. But this is giving you an idea of like what it looks like when a person is enrolled. So when a person is enrolled, for example, if I go to like the sequences and series course, this one here, you see, in the sequences and series course, if I access the sequences and series course, the first thing that I'm going to obviously see is like chapter 1, video number 1. No, I want to go to let's see. Chapter 1 is like 3 marks scenarios, and there's a survey. No, not too complicated. Yada. What am I doing here? Where is this? Oh yeah, this is just a survey of 17 questions. But if I go to the first video here, determining the next terminate geometric series, let's see here. It's just gonna give me a video. Let's see here below. You see here. So obviously this video is gonna load, but let me pause this video here. So it says here below are the four main PDF documents that you will use throughout this course. So you'll have a PDF file, right? This PDF file here basically has the course material. It's basically the course material with everything that you would go through in that course and stuff like that. And then this is boom, you see, one of the questions I was talking about, the exact one that we're going through now. You see, it's in the course, because remember the course gives you access to like different questions, different ways that different questions are asked and stuff like that. So this is one of the PDF files that the courses come with. The other PDF file is the pace setter. The pace setter gives you an idea of like how you can pace yourself, like day 1, day 2, if you're going to just be crunching it out, day 3. So meaning this course you could be done in about 5 days or so if you like go through everything. And then the third PDF is just the formula sheet. And then lastly, you also have like a PDF memo. So obviously like the PDF memo gives you, it's like the full course, but then with everything that would have like written out and everything, you see. So obviously you can imagine while watching the videos, this is basically like what I'll be writing out, so that at the end of the day, this is what you have. So even here I can see what our answer is going to be, because this is one of the questions I've done before. You see here, if for 500 terms, you just need to work out 250 because the others are just zeros. And then it says here the sum of the first 500 terms will be 31,000. So let's actually just go back to what we are doing and put 31,000. Where is this PDF file here? There we go, 31,000. So here we are getting 31,000. Fantastic. So question number 2.3 now. 2.3 looks pretty interesting, or does it? 2.3 says consider the following geometric series for 4 marks. It says determine the values of k. For 4 marks, determine the values of k. Well, this is quite interesting. Okay, it's not that interesting. Like, bro, come on. Consider the geometric series. So if it's a geometric series, then it means that we have a common ratio. That's the first thing to point out. We have a common ratio, of which the common ratio, we know it is just T2 divided by T1, or T3 divided by T2, going on and on and on and on and on. So here they're saying determine the values of k. So determining the values of k, I mean, you may be asking yourself, but then what do you have to do to get the values of k? Like, what's the question? What do you even want is what you may be asking yourself. So yeah, don't overthink it. Just keep things simple. So let me see here. Yeah, just keep things simple. So let's see here. Keeping things simple, what are we going to do? I don't know what we're gonna do. Let me see if I did not make a dumb mistake here. I think everything is fine. Here, let me just make sure I say that therefore the sum of the first 500 is 31,000. You see, I feel like I was distracted here. I think it's essential to put this at the end of the day so that it doesn't show as though you, yeah, whichever way, just put this here, for your own safety, for your own safety. But anyways, for a question like this one here, determining your value of k, what I can safely say is try and use this to help you. You see, try and use this analogy to help you over here. See, so using this analogy to help you, what you're gonna do is T2 is this value over here. You see, you're gonna have 8 with 1 minus k, the whole thing squared, over 5. No, come on, bro. Come on, man. Do better, my guy. Do better. So this is T number 2, ne? T2. T2, we're dividing it by 4 with like 1 minus k, the whole thing with 5. And then here you're going to have the same thing. This divided by that. So the one thing I can safely say here is, yeah, don't panic because we're dealing with fractions and we're putting them over fractions. And fractions, the most hated thing in mathematics here. The most hated thing in mathematics. But it's okay. It's okay. It is okay. Do not stress. So let's say here 8 is like 1 minus k, the whole thing over 5, the whole thing to the power of 2. So the big issue is that here you just want to simplify. You see, one of these cancels one of these at the top. And then 8 divided by 4, that's a 2. So here you're going to get 2 with what? With 1 minus k over 5, like that. Here you're also going to get the same thing. 2 of these cancel 2 at the top. And then 16 over 8 is just 2, 1 minus k over 5. So we now know this is our value for r, you see. Therefore, r is equal to this 1 minus k over 5. So we have basically identified that yes, our value of r is equal to whatever this expression is. So if you're going to determine the value of k, you may be asking yourself, but then how do you do that now? Like, we've gotten our r, now it's like, where does k come in? So the strange thing with questions like these is you have to seriously think outside the box. The reason why you have to think outside the box is because here they just said it's a geometric series. So obviously, if it's a geometric series, the one thing you can think to yourself is, if it's a geometric series that potentially has multiple values of k in this scenario is a geometric series that converges. Let me just say that again. So let's say here has multiple values of k, therefore the sequence converges. I know, right? I know. It's like, what converges? I thought converges. What? Yeah. So as I mentioned, you definitely do want to be thinking outside the box. It converges. You see, because if you look at your sequence, if you look at it nicely, it looks like your sequence is getting bigger and bigger and bigger and bigger and bigger. But unfortunately, that's actually not what's happening here, because the issue is, if you look at it nicely, right, this here is like to the power of 2 to the power of 3, going on and on and on and on and on and on and on. And then depending on what k is, you can easily see that the value at the bottom here, this value at the bottom here, if you're going to have, let's say, something like 5 to the power of 3 at the bottom, that's like 125. The next one is going to be a much bigger number at the bottom, going on and on and on and on and on. So this is clearly showing you that this is actually a value where the fractions are just getting smaller and smaller and smaller and smaller and smaller. Like if you look at the next one, looking at the trend, the next value here looks like it would be like 32 with like 1 minus k over 5 to the whole thing to the power 4. So at some point in time, you would have this top to the power 4, the bottom part to the power 4. And you can clearly see that the denominator is just getting bigger and bigger and bigger. And as long as your denominator is a value that's going to be getting bigger and bigger and bigger, it means that your fraction itself is just getting smaller and smaller and smaller and smaller and smaller. So your sequence definitely converges. If your sequence converges, it means that r is a number that is bigger than -1 or smaller than +1. So in terms of you getting values for k, you're definitely going to need to take this thing here and drop it wherever k is, or wherever r is. You're going to need to take this and drop it wherever r is, and then you can just solve for k from there. You see, solving for k here, it doesn't look like we're going to do any funny business. It looks like we can just multiply by 5 everywhere first, times by 5 over here. So yay, come on, bro. Times by 5 over here, times by 5 there, times by 5 there. This is going to give you like -5, and then this 5 cancels that 5. You're going to have 2 with 1 minus that. And then what you got? Well, you can divide everywhere by 2. So dividing everything by 2, you're going to have -5 over 2, 1 minus k there, and then 5 over 2. And then clearly to get k on its own, you can firstly take the 1 over. So here you can firstly minus by 1 everywhere. So minusing by 1 everywhere, you're going to end up with like -7 over 2 here. And then minusing a 1 here, you're going to end up with like 3 over 2 over there. But then obviously you're not done here, because your value of k is supposed to be a positive value in the middle there. So this is where you need to be super duper careful, because you're about to divide by a negative. So here, divide by -1, divide by -1, divide by -1. So when you do that, because you've divided by a negative, obviously this becomes a positive value, but then your sign has to flip over. This becomes a negative value, but then your sign has to flip over. That is like super duper important, people. Super duper important. And I think we can move on now because, we've been dealing with this question for far too long now. Let us move on. Okay, question number 3, starting with another section in sequences and series. So it says here the first 3 terms of an infinite geometric sequence is 16, 8, and 4 respectively. So this is the key thing here. If it's an infinite geometric sequence, then it means that this sequence has a sum to infinity. If it has a sum to infinity, it means that this sequence has a value of r that is between 1 and -1. That's like a known fact anytime you bump into these kinds of keywords, of which these kinds of keywords are also like the kinds of keywords that we do like make sure that we go through in the course and all that. Like, I'm even so tempted to show you like the receipts, Like, I feel so tempted to show you the receipts because it's just there, it's just there. Like legit though. If I go to like all courses now and you look at like the course curriculum for like the sequences and series, the course curriculum for the sequences and series, it basically does show you that some of the keywords in like the topics that we cover, it is most definitely things like the words that we've just read through now. I just want to show you like the course curriculum for like the sequences and series course. Let me just go to it here. Where is sequences and series? Sequence and series, page number 3. So obviously on the course platform, the entire syllabus is there. So if I go on sequences and series here, right, what you're gonna see is the course curriculum. And looking at the course curriculum, you see there's chapter 1 here, which is like 3 mark scenarios. But then you can see there are certain questions where you can see these are the kinds of words that are highlighted. You see, determining the nth term of an infinite geometric sequence, because obviously we need to know what those keywords mean, you see. And let's see what other keywords. Well, yeah, you see, showing why the sum to infinity of a series exists, blah 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 blah. I think you get the idea. So here it says determine all possible values of n for which the sum of the first n terms of this sequence is greater than 31. I think some of these questions from this Gauteng paper are some of the questions that I had in the course. Like legit, these are some of them. Like most definitely. It says the first 3 terms of an infinite geometric sequence is 16, 8, and 4, right? So you have terms here like 16, 8, 4, going on and on and on. They say to determine all possible values of n for which the sum of the first n terms of this sequence is greater than 31. So without overthinking anything here, they say to determine determine all possible values of n for which the sum of the first n terms of this sequence is greater than 31. So you basically want to work out where Sn is bigger than 31, of which we already know that Sn is just your geometric number pattern Sn formula. So this is like a, and then r to the power of n minus 1, the whole thing over r minus 1, of which, if you think of it, right, where a is, we know what a is, we know what r is. Technically r here is just a half, you see, because 8 divided by that is a half, 4 divided by that is also a half. So yeah, we're good. No, why did I put a quarter? I meant to put a half. I promise. I meant to put the half. Anyways, let's see here. So in our case, we just have to solve this inequality over here. You see, that's why this is just a 3-mark question, because it's really not a big deal. Solving this inequality, we're going to have a, what is a? A is just a 16, right? 16, put here 16 over what? There's r here, which is like a half. N is what we're looking for. The whole thing here is over half minus 1. Where is this bigger than 31 is the question that we should be working out, you see. So let us do this here. A half minus 1. What is a half minus 1? A half minus 1 is like negative a half. So obviously here you're going to have 16 half to the power of n minus 1. the whole thing over negative a half, and then this is like 31. So the issue here is you're going to be multiplying by a half, you see, to get rid of this negative half here. When you multiply by a half, you don't have to flip over the sign. You only flip over the sign if you're dividing by a half, you see. So let it be known, excuse-moi, excuse me. But anyway, so this is going to cancel that, and then you're going to have 16 a half to the power of n minus 1, and then this is going to be bigger than what? Negative 31 over 2. So solving for n, it looks like both sides would need to like divide by 16. And then I'm always wondering to myself, bro, you could have just given yourself like the whole page. But look at you giving yourself half the page. Like, what is that? Huh? Why you gotta give yourself half the page? Now look, you're busy here fishing for space. Nah, that's not fair. And then now look, the things you were underlining that were important, they are gone, but I guess it's okay. So from here carrying on, right, what you gonna do when they come for you, bird boys. So from here we obviously can see we can divide by 16 on both sides. We're gonna have a half to the power of n. Bro, what is going on? Yeah, let's see here, half to the power of n minus 1 on this side. This is going to be equal to negative this divided by 16, of which this negative 31 over 2 divided by 16, we can just put that into the calculator. I think it's going to give us negative 31 over 32. Then here you have this to the power of n minus 1. Obviously the 1 can go over to the other side. You're going to get 1 over 32 on that side. And then here you can just be creative, but you don't really have to be. Just use your logs, because remember, this is a base and this is an exponent. You're trying to isolate the exponent. So anytime you're trying to isolate an exponent, which is n, you isolate it, and then you make the base of the log the base of whatever your base of exponent was. Like, you see, this is the base of the exponent, it's a half. That's going to be the base of the log there. And then 1 over 32, that's like this. And then in the calculator, guess what you are going to get? You are going to get a 5. Because why not? N is going to be a 5 here. Now you may be thinking to yourself, but what happened to the inequality sign? And I think you're right. Like, what happened to the inequality sign? I'm even asking myself the same question. Like, bro, what happened to the inequality sign? Well, nothing happened to the inequality sign. I just literally forgot to put it. I'm supposed to just be putting it, to be honest. Like, I should just be putting it because it is just supposed to be there. So yeah, let me just put my inequality sign and then just show that everything is fine. So here, this was just supposed to be inequality. So excusez-moi over there. So this was just going to be inequality. So n has to be bigger than 5. So obviously if n has to be bigger than 5, then it just means that your value of n, because I mean this is just an arithmetic, this is like a number pattern. If we're saying that n is going to be bigger than 5, then it means that your value of n can be anything like 6, 7, going on and on and on and on and on and on and on, you see. So here, even if you wrote, let's say n is bigger or equal to 6, you see, this is also a viable option, because anything where n is equal to 6 or bigger than 6, those would be values that, those would be basically scenarios where you would have added enough terms for you to at least have a sum that is bigger than 31. Because what they're trying to say is, they want you to work out what's the least amount of numbers that you need to add up for you to at least get a value of 31. You see, like here, if you add 16 and 8, that's going to give you like what, 24. If you add a 4, that's going to give you like 28. If you keep adding your values, you see, at a certain point in time, you will have at least 31. You see, and then the moment you keep adding from there, you'll obviously have something bigger than 31. So here they said, for which values of, determine all possible values of n for which the sum of the first n terms of this sequence is greater than 31. That is how you are do it. So obviously we can move on to the next question, which is out of 2. Calculate the sum to infinity of this sequence. Like, what a nice question, huh? Such free marks. Like, what a wow. So obviously writing down the formula, important. Our value of A, that's obviously like a 16. Our value of R, we worked it out to be a half. And then this is going to give you a 32. You know, nothing crazy, nothing major. You really can just put this down and just keep things moving, you know. We're about to move on to question number 4 now, which is going to be us working on functions and graphs. So I will catch you there, me. Question number 2. No, what am I doing? Question number... Dude, this is question number 4, bruh. How in the world did I go from... yeah, no, that was just weird. But anyways, question number 4 here says, given f of x is equal to this thing here. This is clearly a hyperbola. So it's a hyperbola. Hyperbola. Excuse me. Wait, what did I do? Yeah, I don't know, me. I just maybe thought, you know, maybe someone like with like Ebola is like listening and then they're gonna get offended. But do people still get Ebola these days? I don't know, man. I don't know. But no offense to anybody. It says here, this is a quadratic number pattern. No, bro. It's a hyperbola. Yes, like I'm getting distracted here. This is hyperbola. It's a hyperbola because x is like under the division line and stuff like that. You see, x is under the division line here. And if you look at the first question out of 2, they said, write down the equations of the asymptotes of f. So if you're going to write down the equations of the asymptotes of f, you just need to know your standard form. Your standard form always tells you that this is the x value of the asymptote, the x asymptote, as in the opposite of this thing will always give you the equation of the x asymptote. So these 2 here, you always take the opposite. So your first equation, you'll have to say x is equal to -2. It's like a rule of thumb there. You always take the opposite of the x. And then for y, this will always give you the y value of your y asymptote, but this one you take it as it is. So here it will be y is equal to -1. You see, all these basics, you can definitely find them on the main channel. So obviously on YouTube, on the main channel, #bright young brains. I'm not connected to the internet. Oh, Zion. Hey, next time, hey? Next time. I will show you next time. Just now. Hey, no, never mind. Anyways, let's move on to the next question here. It says, calculate the y-intercept of f. What is the y-intercept of f? Oh, f is a hyperbola. I mean, getting the y-intercept of f, you just make x equal to 0, my guy. Yeah, we're just going to make x equal to 0 here. So here we're going to say y is equal to 6 over 0 plus 2 minus 1. Simplifying here, you're going to have 3 minus 1. And then your y is going to be equal to 2. So when you get a y-intercept, try to write it as a coordinate when you're done. So here the x value is just a 0. The y value is just a 2. You see, you'll get your marks. So as I was saying before, my internet rudely interrupted me. With the main channel, right? Come on, bro. Come on, load quickly, man. Load. The people want to see. If you go on the main channel, right? The main channel is definitely Bright Young Brains. Don't go for 12k subscribers. Thank you very much. So here, if you want to like access content on the course platform, I mean on the channel, the best thing you can do for yourself is to go to like the playlists. You see, if you click on playlists, you'll see these are the different playlists on the course platform. And with these, I wanted to point out like the functions and graphs playlist specifically, because if you go to like the functions and graphs playlist, what you're going to see here is obviously you have like a 5-minute clip on like the basics of a straight line graph, yada yada yada, and you can see on the basis of like a hyperbola, you can see it's just like 6 minutes. You see, it's like super short. So you'll be able to like see all these things that we're talking about here. You see this and that, all that shandies. So for 3 marks here, they want us to sketch the graph clearly showing the asymptotes and the intercept of the axis. Wow. So drawing this is not going to be too difficult. You're just going to draw your Cartesian plane over there. Now the issue with sketching a graph, especially if it's a hyperbola, always do your asymptotes first. You see, like here, the first asymptote is that x is equal to -2, because we said you always take the opposite of this one. So where x is a -2 is going to be somewhere here. You don't even need to do like different numbers here and then different numbers there. No, just make sure that your sketch is proportional. So you're going to label this -2, and then you already know that this is like your x asymptote, right? So let's do this here, dotted line. And then your y asymptote, we are seeing that it is where x is equal to -1. So let me actually put this in another color, you know, just for the vibes. X is equal to -1 is your other asymptote. So if you're going to keep this proportional, you may want to make this like a -1 there, and then you do your dotted line. So the other thing that you need to remember, and if you've gone through like a few of these over the days or whatever, you'll know that with a hyperbola, we always say that this value here will always give you the shape. You see, this will always give you the shape, in the sense that wherever your asymptotes are, right, you need to look out for your asymptotes. Your asymptotes always should guide you with regards to where your shapes go. So we know that if you think of a Cartesian plane, going up it's plus, going down it's minus, going to the right it's plus, going to the left it's minus. So if your a value is a plus, it means that you're going to have a curve in here, you see, because up is plus, to the right is plus. You're going to have a curve here. And then if a is a plus, your other curve is going to be down here, because you see, this is where minus and minus meets. You see, this is for where a is a plus. Obviously, if a was a minus, then it means you'd have your curve in here and your other one in there. The reason that's important is because, I mean, like, look, in our case, a is a plus, so automatically we know that our curve is gonna go there without even thinking about it. No, bro, the other one, bro, the other one. We already know that our curve is gonna go in there. Excuse-moi. What do I need to do? Yeah, we know that one of them is gonna go in there, and then the other one is gonna go in here. But before I draw the curve in here, I am just going to label the intercepts so that we draw an accurate picture. So the y-intercept we already have. It is where x is 0 and where y is at 2. So proportionally speaking, that's like there. That's the y-intercept over there. And then the x-intercept, we can just get that by making y as 0. So in our equation of our hyperbola, let us get the x-intercept, because we want to accurately sketch our graph, you see. So I'm just going to I'm going to change this thing here. We're trying to solve for x, right? So this is x. This, we can make it a 0, like that. And let us see what we do. Let's see what we do. So here we can take the 1 over. That's going to be like a positive x plus 2. And then here you can just multiply everything by x plus 2. Both sides. You're going to have x plus 2 here equal to 6. And then here x is just going to be equal to 4, you see. So it just means that where x is a 4, that's going to be your other point, like somewhere over there. So your sketch, clearly you can just make sure that it goes through there. Wow, bro, you can really dance. Wow, you can really dance. I feel like I'm, yeah, TikTok, ne? Yeah, ne, that thing. Yeah, it is what it is. That's f of x. We have labeled the intercepts, check. Asymptotes, check. Well, and we have a sketch, check. So we're good. Let us move on. So here it says determine the equation of the line of symmetry of f that has a negative gradient. And then it says leave your answer in the form y is equal to something. So the big issue with these kinds of questions is that they're easy. Wait, how is that a big issue now? Okay, it's not a big issue. It's just like, just know these things. You see here, the line of symmetry that they're talking about is this one here. There's a line that passes through this point. You have two of them. You have one that has a positive gradient. You have one that has a negative gradient. You see, all this is covered in the courses. Like legit. Honestly speaking, if math is not your friend, ne, I have made these for you. Because math also was not my friend once upon a time, you know. So the courses are there. to show you that if I can did it, you can did it too. Yeah, that makes no sense, but I think you get the idea. So here, the line of symmetry that they're referring to is the one that has a negative gradient, because there's another one that has a positive. There are two lines of symmetry for a hyperbola, you see. One that has a positive gradient and one that has a negative gradient. Like here, this one is the one that has a positive gradient. This is the one that has a negative gradient. So they want us to get the equation of the line of symmetry that has a negative gradient. So getting this equation of this line of symmetry that has a negative gradient, let me actually just show it here for now. This here, whatever it is, you want to always remember that its gradient is always a negative one. Always. The positive one, the gradient is always a positive one. So here we know that y, automatically it is equal to negative x plus c. For you to find the y-intercept, luckily you can just throw in a coordinate that the graph passes through. And the good news is the coordinate that the graph passes through, you already know that the x value is a negative 2 there. The y value is a negative 1 there. You see, that's a coordinate, you see. You already know it, negative 2 and negative 1. So that's the coordinate you can use for your straight line and get the full equation of this straight line, you know. So let's do this here. This is like y minus y1 m and then x minus x1, the formula that everybody loves. If you throw a coordinate here, you're gonna have our y value is a positive, is negative 1, right? So this is like plus 1, m is a negative 1, and then here you're gonna throw in a negative 2, so this is like plus 2. I actually hardly ever used this formula, but I have come to like it, you know. I have come to like it. Here you can just multiply the negative inside, and then the one goes over. That's going to be like a negative that. Here you're going to have y is equal to negative that minus 3, which kind of makes sense because you see down here, proportionally speaking, that is going to be like a negative 3. So this will be the equation of your line that has a negative gradient. So you can imagine, this is like super important, you know, super important stuff, but now you know it. Now you know it. Let us move on. Let me remove this thing here so that it doesn't look like it has to be there for your sketch. Moving on to question number 5. We can do that. We can do that. Okay. Let us see here what we got. It's question 5. There's this one day, this one comment of this one person. They thought I was Indian. I don't blame them, man. I don't blame them at all. I'm like, you know, it is what it is. It is what it is. Like, if I one day end up marrying an Indian, now I'm not going to be surprised. Like, I'm not going to be surprised. I'm just putting it out there. So don't be surprised. Don't be surprised. Don't say I didn't tell you. Anyways, question 5 here, it says, P of x is equal to log 3x. The annoying thing with the way this question is given out, ne, is that it makes it look as though the what you may call, it makes it look as though the 3 is like together with the x, but then that's not the case. This 3 here is like the base of the log, so this is actually log 3 with the x here. Yeah, let's just clarify. Equal. My guy, come on, man. Why are you doing this? Yo, nah, goodness. Yo, this guy. Uyenzani, man. What is he doing? Trying to fix it. Oh, goodness. Wasting time. Anyways, that's what this is. It says here, write down the equation of the inverse of P. Write down this, right, which is the inverse of P in this format. So luckily here, all you have to do is you already know that where P of x is and where x is, you're just swapping things around. You see, x becomes y and then y becomes x. So let me write here, x becomes y, y becomes x. So where P of x is, ne, you're gonna have the what you're gonna have, P of x here, that's y, ne? So you're gonna replace that with x, and then you're gonna have log with a 3 there, and then y over here. Now the good news is, remember the base of your log, remember that's always like the base of your expression. And then this value over here always represents an exponent after it has been isolated. So making y the subject of the formula here, you just have to remember that this will be the base, which is like a 3. The exponent is just going to be a x. And then that is it, So if you want, you can then just write the y first, just in case, Just in case you have somebody that's like, why did you not put y first? It's like, but it's the same, mem, Anyways, 6 marks. Yo. Okay, let us grab those 6 marks. Because, why not? So, excuse me. Like, I really don't want to be burping right now. Like, bro, how much of this video are you going to edit? Like, hey, be careful, man. Be careful. Anyways, let's see here. What you got. So we have drawn a cut. I haven't even read the question, and I already want to like write stuff. Boso, what is doing? Here it says, sketch in your answer book the graphs of P and the inverse on the same system of axes. Show clearly the intercepts of the axes and one other point on each graph. That's not too bad. So the issue is, obviously, it looks as though it's easier to draw the inverse, because the inverse, we already know that if your x values are increasing, your y values are also increasing. So we already know that the inverse here, if you look at it, y is equal to 3 to the power of x. The asymptote is a 0, you see. So we know that the asymptote runs along your x-axis. That's the one thing that we know. And if x is increasing, your y values are increasing. So already the sketch looks like this. You see, that one is like a no-brainer. You see, the reason I'm drawing this one first is because it's the easiest one to draw. It's easier to draw this one. Because obviously you know that its inverse, it is just going to be a reflection. So you have this line here, you have this here, and it is always good practice to label this line here. Now, if you have been studying and planning and preparing, you already know that the inverse of a picture that looks like this, right? It has to be an image that goes like that. You see, this is almost like standard information or standard procedures, yada, 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 you see. So this is the log graph here. This is the inverse. So you see, it was easy to draw this one first because this one, it's just like has to be a mirror image. So they said we should also show the intercepts and one other coordinate. So this point here, we know it's already always going to be a 1. The reason we know it's going to be a 1 is because if you throw x as 0 here, your y value comes out as 1. And because these are reflections of each other, if it's a 1 over here, it's definitely going to be a 1 over there, you see. Anyways, they said we should show any other coordinate as well. So if you're going to show any other coordinate, the good news is you can make it whatever you want, you see. You can just throw in a coordinate in your graph and then just plot it. So they say it's here, one other point on each graph. So the good news is you can just get a point for the inverse. If you get a point on the inverse, let's just make x a 2 or something. So if you make x a 2 on the inverse, you're going to have y is equal to 9. So here, let's plot this point. We can need to show here x is a 2, y is a 9. Now on the inverse, it's going to be flipped over. So you can just put here a 9 and a 2. And then you'll just have 2 birds in one stone, you see. In one stone, with one stone, bro. Come on, stop watching the phrase here. 2 birds with one stone. But why are we killing birds now? Yeah? Save the birds. Put your stones away. But anyways, what you got here? Yeah, that's how you're going to get the other coordinate. You can just literally choose any random x value. And then get the corresponding y value. And then you are sorted. So let us move on. Let me see. I make sure I didn't get anything. Yeah, I make sure I put everything there. Yeah, that's all good. 5.3 says determine the values of x for which the original graph is smaller or equal to 2. So you want to work out where p of x is smaller or equal to 2. So that's quite easy. Coincidentally, we have worked out where the graph is equal to 2, but let's just start from the top. P of x here, it is this equation. P of x, it is equal to log 3x. they said where is p of x smaller or equal to 2. So we technically need to work out where is this thing here smaller or equal to 2. So the easiest way to work this out is, likely we have a sketch. Just think of what we do when we work out a quadratic number, a quadratic expression. We usually have a sketch to help us. Likely here we have a sketch to help us. You see, this graph here looks like this. You see, now you want to work out where is it below 2. So for you to work out where is it below 2, you have to find out where it's equal to 2 first. And then the part that is below 2, so obviously here this will be a y value of 2. You see, the part that is below 2 would obviously be this part over here. You see, and this part that is below 2, it's obviously x values from here going to the left. You see, that's the way you're going to answer this question. Determine the values of x for which this is smaller or equal to 2. So if you're going to work out where it's smaller or equal to 2, you might as well find out where it's equal to 2 first, you see. Because if you find out where it's equal to 2, you will find out which x value this is. And then you'll be able to say your graph is below 2 starting from this x value all the way to negative infinity. But you may be asking, how did I get the 9? You can just throw a 2 in there, you see. Log 3x, where is it equal to 2? We already said this is the base, this is the exponent. So x here is going to be equal to base exponent. X is a 9. So we're seeing that the graph is below 2 from x going all the way to negative infinity, but then not negative infinity actually. It stops at 0. We have to be careful because 0 is like an asymptote there. So let me make sure this arrow does not look like it is going forever, yeah, because it's stopping somewhere. Let me even put a round dot there just to be funky. So here we have to say, therefore, our x values have to be between 0 and 9. You see, x has to be bigger than 0, or x has to be smaller or equal to positive 9. You see, because between 0 and 9, that's the portion where the graph is below 2. And that is how you answer this question, you see. The course on functions and graphs goes deep into these things. So again, I advise you to check this out and do not regret it. I mean, like if you're writing prelims now, finals are just around the corner, you see. You might as well, you know, go all out now instead of you coming back next year and you're sapping. You know, that's always really depressing, you know, thinking that, you know what, I might as well have just done it once and then now you're doing it again. You see, don't be that guy. But anyways, here it says you write down the x-intercept of h if h is the graph of p after you've thrown in negative 1 into it. So the graph of p, it is technically this graph here, log 3x. If you throw negative x wherever x is, you're going to have log with a 3 here and then that. You see, this is the graph of p if you throw in a negative x, of which they said whatever this is just the graph of h of x. So when you see this thing here, they say just replace it with h of x. So this new graph of h of x, they said we should find its x-intercept. Well, that's easy because getting the x-intercept, you just make y a 0. So here we can just say, therefore, 0 is equal to log 3 with x as a negative, you see. And then we said if you're going to solve for x here, technically we know that you just need to say this is the base, this is the exponent. So here it's going to be, therefore, base exponent is equal to negative x. Anything to the power of 0 is a 1, you see. So here you're going to say, therefore, your x value is you're going to divide both sides by a negative here. So you're going to get negative 1. There we go. You can write this swapped around. If you don't, I really don't think it's an issue. Or I can safely say it's really not an issue. So don't stress about it. So here we said if you're going to get an x-intercept, try and write your answer as a coordinate. You see, like how we got that y-intercept up there. Put your answer as a coordinate so that you don't get penalized for unnecessary things, you know. That is that for question number 5. Well, let us move on to question number 6. Question number 6. Question number 6. Let us go. Let us go. It looks like we're working with a parabola. Which of the functions is my favorite? I can't even think. I can't believe I actually asked that question. Like, what kind of a question is that? Hey, I don't think I have a favorite, It's even weird thinking about favorites when people actually hate functions as a whole. So let me not offend anybody, It says here the sketch below shows the parabola this. And then what we got here? Somebody commented on the channel, Emmanuel, hi, can I ask, is there a difference between final and prelim? I'm assuming that's probably what this person asked. Nope, go back. Oh no, wait, I can answer that question. No, I'll do it later. Like, I'm busy. Anyways, you're not, and you're seeing what time I'm recording this here. You see, putting in the work, guys. Putting in the work, okay? Putting in the work. Look at what time it is. Look at what time it is. Wait, yeah. Am I gonna edit this thing? I don't think so. I don't know. We'll see. We'll see. But if you look nicely, today's date. Never mind. I'm getting distracted here. Yeah, let's see. The sketch below shows the graph. The sketch below shows the parabola f of x with turning point this. And y-intercept 0, coordinate 5. Then it says here, for 5 marks, show that the equation of the parabola can be written like this. So, I mean, if you're going to get the equation of a parabola, always start in completed square format. That always works. If you don't start it like this, you're going to bump into problems. Because when you start it like this, you can fill in things like a, and you can work out a immediately because your theory helps you here. Because here you have x and you have y. No. That's p and q, bro. Brody, that's p and q. Come on. You have p, you have q. And then here you have x, you have y. You see four things. 1, 2, 3, 4. The only thing missing is a. You see? Easy peasy. Lemon the squeezy. So y, it's like 5. A is what's missing. X is like a 0. P is like a 2. Because you always take the opposite. If it's like a positive 2 here, make sure you're putting a negative 2 here. If it was a negative 2 here, make sure you are putting like a positive 2 here. Always the opposite. For Q, you take it as it is, you see. This is how easy these questions are, guys. Because you just need to know your theory, If you know your theory, you're good to go. So here, this here squared is going to give you a 4. And then solving for a here, this is going to be like 5 minus 3. This is like 4a. This is like a 2. This is 4a. Dividing by 4 on both sides, your value of a is going to be a half. So therefore, it's going to be in completed square format, yes, but you're going to need to just FOIL it out and everything. You'll have what they have here. So here y is going to be equal to a half. And then x minus 2. And then plus 3. So you just have to simplify here. Oh, I forgot the squared. Simplifying, you're going to have 1 over 2 here. This is like x minus 2. And then another x minus 2. Like that. Let's see here. X minus 2, right? And then plus a 3. So this is like y is equal to 1 over 2. X and x is going to give you x squared. This and that is going to give you negative 2x, and then positive 4. Cool. That is the way. I like it. Then there's like a half here. Why did I just do that? That is so random. Like, what is the hell, man? The plus 3. Keep the plus 3 out because you're going to mess up if you don't put the brackets, you see. Because now this tells you that, okay, you're just going to multiply the half inside. That's going to be like a half x squared. And then like negative 2x. And then like positive 2. And then the 3 can come to play now. And then this is like your final answer. Squared. This is just on its own. And then 2 plus 1 is like a 5. And then look, It's exactly what they have, man. It's exactly what they have. Who in the, who in the hell put the muffin in the freezer? I did. What you gonna do about it? TikTok vibes, man. TikTok is one of the best things that have happened in the 21st century. One of the best things that have happened in the yo, never mind, let me just carry on. Don't get distracted, bro. Focus. It says here, without calculating the discriminant. So remember, the discriminant is this thing here. What is the discriminant? It's delta. It's this thing, b squared 4ac. They said without calculating the discriminant, you should give an appropriate reason whether the discriminant of this is positive, negative, or 0. That's for 2 marks. Okay, without calculating it, you should give an appropriate reason of whether the discriminant is going to be a positive number, a negative number, or 0. Wow. Oh, okay. This is where theory comes in, you see. If you have watched, if you've gone through what you may call, if you've gone through what now? Yeah, if you've gone through like the nature of roots course and stuff, you'll note that for a scenario like what we have here, this image is a graph that has no real roots. You see, this graph has no real roots, because if you look at it here, this graph has no real roots. You see, it has no real roots because it's not touching the x-axis at all. So if it's not touching the x-axis at all, it means that your discriminant is a negative, because if your discriminant is a negative, it means that delta is smaller than 0. When delta is smaller than 0, you know that your quadratic formula will always give you an error, because obviously in your quadratic formula, x is equal to minus b plus minus, and then here it's like b squared minus 4ac over 2a. So this thing here is your discriminant. You see, let's change its color. Boom. This value here, as long as it's a negative, that's the only reason why this will have no roots. You see, when this is a negative, because you cannot have a negative under a square root. So for our 2 marks, we're going to say here, the discriminant is a negative because the graph has no real roots. You see, the picture is showing us that. And then you get your 2 marks. For 2 marks here, they said use the graph to determine the values of k for which the equation this has real and unequal roots. So for only 2 marks, right, here you have to know your theory as well, you see, which is what we're going to showcase here. All these things, trust me, the courses go through these things, Iso. Because remember, there's a whole nature of roots course, or rather, it's actually just the, what you call, it's actually just the, it's a what? It is actually an algebra course. It's like a question 1 course, a course that basically goes through like what you need to know specifically for like question 1 and stuff, of which in that question 1 course, one of the chapters is purely just what you may call nature of roots, you see, of which in the nature of roots course, I mean, like you can imagine, in the nature of roots chapter, you basically go deep into like nature of roots and stuff like that. I just want to show you and I cannot find it. Oh no. This is embarrassing. Let me say algebra here. Algebra. Let's see if algebra shows up. Algebra, come and save me, please. Like, come on now. Algebra. Oh no. I feel like I should pause and look for it, because I'm embarrassing myself. No, I'm not. I'm just trying to find it and I can't. Like, I really can't. No, I think it's 8 and 12. You see, 8 to 12. If I click on 8 to 12 here, it's going to show me, boom, there it is. You see, this is nature of roots, inequalities, and algebra. So in this course, obviously, if you check like the course curriculum, chapter 1 is things like solving for x, but then there's a whole nature of roots section here, you see, where there's like 1, 2, 3, 4, 5, 6, 7 lessons. And you can imagine these 7 lessons are going to, like, you know, they're going to plug you so hard. So here, if they say use the graph to determine the values of k for which the equation this has real and unequal roots, the best way to look at this question is just know how the roots behave. So what you need to keep in mind is this graph, the turning point is at where y is like a 3. So here we know that the y value is like a 3. You see, let me actually just point that out. You see here, what we know here is that the y here is a 3. Now the way it looks, originally it has no real roots. So this expression here, right, if you take k to the other side, you're going to have here half x squared, and then what else, half x squared minus 2x plus 5. If you take k to the other side, you're going to have minus k. Let's actually put the minus k in another color, minus k, and then this is equal to 0, you see. So what you want to recognize is that the minus k there is moving the graph downwards. You see, this here moves graph down. Let's say moves graph down. You see, this here moves your graph downwards. So they're asking us here, use your graph to determine the values of k for which the equation this has real and unequal roots. So for this thing to have real and unequal roots, we just have to determine how many units must our graph be moved down. Because as long as our graph is moved down, there's a specific number of units that we can move it downwards for it to start having real and unequal roots. And this is what I mean. If you look at your image, right? Oh wow, oh goodness, no, go back, bro. If you look at our image, if we look at our parabola over here, we can clearly see that for us to start having real roots, this implies what must happen for us to start having x-intercepts. For us to start having, does that even make any sense? For us to start having, it does make sense. Yeah, for us to have like x-intercepts, right, you can clearly see that your graph has to be moved down a minimum of 3 units. The only thing is, if you move it 3 units exactly, then the graph will have equal roots. For you to start having roots that are not equal, your graph needs to be moved down more than 3 units downwards, you see, because if you move it exactly 3 units, your graph will have equal roots. Because any scenario where they talk about equal roots, it's a scenario that's implying that your graph has one x-intercept. But then if they talk about unequal roots, they're talking about a scenario where your graph obviously has more than one x-intercept. So let me take this image here. If you have moved it, if your k value here is technically a scenario where your graph has been moved down more than 3 units, that's the only scenario that qualifies for the question that they're asking us, you see. The question asked us for which values of k will your graph have real and unequal roots. So technically it will have real and unequal roots as long as our graph has been moved down more than 3 units. So let me actually write that in words first and then write it as an answer. So here we can see that, let's say here graph has to be moved at least, or let's say it has to be moved more than 3 units downwards. You see, it has to be moved more than 3 units down, you see. So if our graph has to be moved 3 units down, clearly our value of k just needs to be smaller than 3, you see. Because if our value of k is smaller than 3, or rather, if you look at this value, actually here, let's actually look at this. K technically needs to be what? The funny thing about how we're going to answer this question, right? We're actually going to need to say K has to be bigger than 3. The reason why we have to say K is bigger than 3 is because if you drop a 3 here, obviously a number that is bigger than 3 is you dropping a 4 there, of which if you drop a 4 there or something like that, you will still just be moving it 4 units downwards because there's like a negative in front of the 4. If you drop like a 5 over here where K is, it still just has a negative in front of it. So this will still be moving it 5 units downwards, going on and on and on. It's obviously also not to imply that the values of K are only going to be integers. We're just going to say that K has to be bigger than 3. Because if you drop any number here that is bigger than 3, that number, because you have a negative in front of it, it will always be showing that this graph is being moved downwards, going on and on and on and on and on. So you can imagine bumping into these kinds of questions once off, like, you know, it's not gonna really help in terms of you really understanding how these questions work. That's why, you know, the nature of roots course is really gonna help. But obviously before that, there's a nature of roots playlist in here that gives you like maybe the basics, because normally on the channel, right, the idea is on the channel we go through like, you know, it's more like crash courses on like understanding the topic, and then on the course platform we basically go deep into like different topics. So the nature of roots playlist here will basically give you a rough idea. You see, like here, this tutorial here gives you like the basics of nature of roots. So even if I click on it here, and if I look at like the thumbnail, let me just pause this thing here, skip ad, thank you. I want to see the thumbnail. Give me the thumbnail, please. Snap, I paused at the weirdest spot. But if I skip over here, you'll see that basically you can see that these tutorials on the channel, you see, they'll give you like the basics, but then on the course platform we basically like go deep into the different topics. So that's how you can better understand these kinds of questions. Question 6.4 for 1 mark here, it says the parabola is shifted vertically until the new y-intercept is the origin. Determine the equation of the new parabola. So this question is quite simple because your y-intercept is starting off at positive 5. So if this graph is like shifted until it has a y-intercept at the origin, clearly the graph has been moved 5 units downwards, you see, because it's starting from here. The distance here is just 5 units, you see. So the new equation, did they ask for the new equation? Yeah, they did. So luckily here, yeah, it's really not going to be an issue. The graph has just been moved 5 units downwards. So it just means that this graph here, you have to minus 5 from it. Like you see, the equation of the graph here, you're just going to remove 5 from it. Where is it now? There. There's our equation of our graph, you see. So this graph being moved 5 units downwards, it means that the whole thing, you just have to subtract 5. So let me do this here. Copy that. The equation is just this thing here, minus 5. So here, you're going to just subtract a 5. So here you're going to have, therefore, y is equal to this squared minus 2x. That is it. That is it. We can move on to question number 7. Coincidentally, as we are about to start with the financial math section, somebody has asked a question. Hi, can I ask, is there a difference between final payment and total paid? Yeah, there's a difference between final payment and total paid, because final payment is like the last payment that you make on a loan. Because obviously if you're going to be paying off a loan, right, over like 3 years, you have like a specific monthly installment that you make. But then as you're making these monthly installments, the amount that you owe is just getting less and less and less and less and less. So eventually you're going to owe an amount that is less than your installment, you see. So that amount that will be less than your installment, this will be like the final payment. Because say like your installments are like 5,000 rand every month, your loan is just going to get lower and lower and lower and lower and lower. And then at some point, you're probably only just going to be owing 1,250, you see. So you won't need to pay the full 5,000 to pay off your loan. You'll just have to pay 1,250. So that's like your final payment. Total paid refers to everything that you would have paid over your period of paying off your loan. You see, that's the difference between the final payment and the total paid, and that is something that I will write down to respond to Emmanuel Mungoma. Okay, we are currently recording for the what? For the other channel. I think that question came into like the main channel, which is like Bright Brains. But anyways, let us carry on here. Sarah's investment and interest at 11% per annum, compounded monthly. Okay. That is nice. So they said here, no, compounded semi-annually. Where did I get monthly from? Like, bro, what the hell, man? Read nicely, man. Come on now. Yeah, it's semi-annually. So semi-annually means that you're going to divide your value of I by 2. And then it says here, Sarah's investment earns an effective interest of 11.42% per annum. Whose investment? Sarah's. Oh, that's Mary. Oh, snap, bro. I meant to say Mary when I read Sarah. When I said Sarah again, I'm sorry. So two people, ne? Sarah's investment is 11% per annum, compounded semi-annually. Mary's investment, it earns an effective interest of 11% per annum. And then it says whose investment, Sarah or Mary, whose investment, Sarah's or Mary's, earns a higher rate of interest per annum. So this is quite an interesting question. So what makes this question interesting is because if you're given an interest that is compounded semi-annually or monthly or quarterly or whatever, you need to get the effective interest of this for you to find out what is the interest per annum, you see. So let me write a note here. The effective interest, effective interest is the interest rate per annum, you see, because obviously what they would have given you is like something that's like semi-annually. So for you to get the interest rate per annum, it is literally just a matter of you getting the effective rate, because here they gave Sarah's one, it's already the effective rate interest. So hers it's already per annum, but then this one it's not per annum, it's compounded semi-annually. So the semi-annually one, we have to get this in terms of its effective rate interest, or rather we just have to get the effective rate interest of the 11% and then compare it to the 11.42 to see who is getting a better return on the investment, you see, because effective rate interests, they give you an idea of like how much interest is actually being accumulated on a yearly basis. So for Sarah, we just have to get the effective rate of this value over here. So the effective rate interest formula, it is literally just 1 plus EFF. This is equal to 1 plus I nominal, the whole thing over M, the whole thing to the power of M. So M represents the compound. If it's annually, this will just be a 1. But you see, that's you won't have to use the effective rate interest formula if that amount was like annually. Because it's semi-annually, it just means that your M is going to be a 2. And then we're working out the effective rate interest here. So the nominal interest is what we're given here, which is just 11. So here I'm going to write down the percentage symbol because that's what I put in the calculator. This is over 2, like that. And then the effective rate interest, this is clearly just 1 plus this whole thing here, which I'm going to put in the calculator. We're going to subtract a 1 there. And then obviously we know that when it's all set and done, we have to multiply this thing here by 100 so that we get our final answer as a percentage. You see, so much space that I gave myself. So nice. It feels so good, man. It feels so good. So all this into the calculator. As a percentage, it comes out as 11.30% if you round it off to 2 decimal places. And clearly, therefore, Sarah has a higher investment here. So Sarah or Mary, no, bro, it's Mary, man. Because Mary has 11.42. This one is for Sarah, you see. So Mary has a better investment. So Mary has a better, let's just say Mary has a better rate, because why not? That is that for that question. Nothing crazy, nothing major. And remember, this PDF file, what am I gonna do? Yeah, this PDF file, I'm just going to upload it onto the course platform, because on the course platform there's like a section where I put like PDF files of like the papers that I like go through and all that shandy. So you see here, there's a portion here that's written, where is it? Grade 12 past papers. So far as of this recording, there's obviously just the grade 11, I mean the grade 12 supplementary paper. Like for example, the guys that wrote in 2020, right? When they were like upgrading, the ones that were upgrading in June wrote this paper here. So obviously that's already on this channel. That's where you can get it. And you see here, this is not like something you have to pay for. You'll just find the PDF file of what we're doing here somewhere. I'll just link it in the description. But anyways, 7.2 for 4 marks. It says Buhle. I said that 100% correct. I think Buhle means beautiful, right? Or beauty. I don't know, but I think so. It says here, this person, right? Yiri Pesuana decided to do what? What did they decide to do? They decided to start saving before retirement. And then it says here, she makes payments of 10,000 Rand monthly into an account yielding 7.72% compounded monthly. Okay. And then it says, starting on the 1st of November 2016 with the final payment on the 1st of April 2026. For 4 marks, it says calculate how much will be in the savings account immediately after the last deposit is made. So questions like these, don't panic. I mean, it's an investment, so it's her money. So the first thing you can do for yourself is to write down the future value annuities formula, because she's making monthly installments, you see, and it's her money. So you're definitely going to use the F formula. The P formula is if it's a loan. You use that if it's a loan and it's you paying off money that you owe. She doesn't owe any money here. It's her money. So what we know is that here our X is our monthly installment, which is just 10,000. Interest, they said it is 7.72% over 12. Because it's compounded monthly. Now for the one we have been waiting for. What is the value of n, and how do you even work out the value of n? So here, don't be in a hurry here. Just work it out systematically. What you're gonna do for yourself is just think of the simplest way to get this. So obviously from November 2016 all the way, let's say here November 2016 all the way until, let's say, November 2015. No, 2025, bro. What the hell are you doing? Excuse me. So obviously November 2016 until November 2025. How many years are those? Let's see here. November 2025 minus 2016. That is actually 10 years. This is very important, people. From 2016 to 2025, it's 10 years, not 9 years, because in your calculation, obviously there's a calculation from 2025 to 2016. Oh, let me see here. What I do? Yeah. So what I do? Let me say here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I think let me not make it confusing. Because here, obviously, from 2016, right? This is like 2017. That's like a full year, 1. And then 18, 19, 20, 21, 22, 23, 24, 25. Yeah, it's definitely 9 full years even though it's like 10 years in total, because 2016 all the way to like 2025, it's definitely 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. However, in terms of like the payments that are going to be made, it's definitely just like one period, another one, and then a third one, fourth, fifth, sixth, seventh, eighth, ninth. You see, so between November 2016 until November 2025, this is basically just 12 payments times 9 years. You see, let's work it out like that for now, before we worry about the year 2020. Before we worry about the year 2026, let's worry about this portion here first. Let me just color code this differently so that we don't get confused when we look at the PDF file. So yeah, between November 2016 and November 2025, let's see how many months those were. You see, let's basically see how many payments those were. So this in your calculator, I think it's going to give you my 12 timetables. They don't want to come to the party. This is like 108 months. You see, 108 months. There we go. So apart from this, what we now know is that obviously after November 2025, you're going to have December, January, February, March, and April. You see, there you go. So from 108, if you look at the months that you're going to add, you're obviously going to add, let's see, November, right? Then there's like December here, January there, Feb, and March, and then April. So obviously from 108 months, it's 109, 10, 11, 12, 13. But then really though, yeah, you see, these kinds of questions that you really do want to be careful, because if you're not careful, you're gonna get the wrong value of n. Because here, obviously, let's read the question again. They said here, Buhle decided to start investing before retirement. She makes payments of 10,000 into an account, yielding 7.72% per annum, compounded monthly, starting on the 1st of November 2016. And then it says here her final payment is on the 1st of April 2026. And then here it says calculate how much she has in our savings account, yada yada yada. So here November, December, January, Feb, March, April. So we said from here we know it's like 12 years, right? 9 years times 12 months. This has given us 108. So 108 here, we're going to add 1, 2, 3, 4, 5 more payments. That's actually going to give us 113 payments. So let's put here plus 1, 2, 3, 4, 5. So these 5 that we have added at the end here, you have to be careful in the sense that in the beginning here, right, there's a payment that was made on the 1st of November. You see, there's a payment that was made on the 1st of November here. You see, so there's like one payment on the 1st of November over here. And then there is your 12 times your 9 payments, and then the 5 at the end of the investment period, which is like inside 2026. You see, let me repeat. They said here she makes deposits of 10,000 into her account, compounded monthly, starting on the 1st of November 2016. So on the 1st of November, she makes a payment, right? That's like the first payment. And then we can clearly see that 9 years pass. So 9 years of payments. 9 years of payments. You see, that gives us 9 times 12 years. And then plus 5 more months. You see. So it's going to be the 1 here plus the 108 plus the 5 months. That's going to give us a total of 114. So let's just check that in the calculator. 1 plus 108 plus 5, this is giving us 114. That's going to be our value of n there. So these kinds of questions, you can clearly see, yeah, they are kind of tricky here. They are kind of tricky because you can get thrown off very easily, very easily. But anyways, let's just throw everything into our n formula, into our fn formula now, or in our f formula rather, and then just carry on. So here, our value of f, may color code it, maybe put like a red. Our value of f here is just 10,000. And then 1 plus I we said it was 7.72%. And then make sure you put the percentage symbol in your calculator as well. And then it's compounded monthly. And then here everything is over 7.72% over 12. And then your final value in your calculator, let us see here. In the calculator, we should get 1,674,501.44. You see, that's how much she has in the account. So questions where you see that the months don't like align. You see, if it was from like November to November, that would have been a bit of an easier question. But I mean, yeah, you know, excuse me, I'm yawning here. Hey bro, we are yawning. Are you tired? I don't know, maybe just a little bit, but we gotta keep on going, man. Just gotta keep on going. Like, why not? Anyways, let's move on to the next question. The next question here says, at the end of the investment period, Buhle, oh, excuse me, just in case like a Buhle is listening. Excuse me. Yammer. At the end of the investment period, right, Buhle reinvested the full amount in order for her to be able to draw a monthly pension from the fund. Let me read again. At the end of the investment period, Buhle reinvested the full amount in order for her to be able to draw a monthly pension from the fund. So basically what it means is this 1 million something here, she did not take it out of the account. This almost just implies that instead of her making 10,000 Rand deposits into the account, she was now, you know, taking money from there eventually. She's just going to leave the money to like grow, and then later on she wants to like start taking money from there so that she can like live off it. So here it says here, she reinvested the money at an interest rate of 10% per annum compounded monthly. And then it says here, if she draws an amount of 30,000 per month from this investment, for how many full months will she be able to receive 30,000? So this is an interesting question. The reason why this question is super interesting is because it allows us to showcase something that I mentioned in like the financial maths playlist. Because in the financial math playlist, there's a section where I spoke about when to use the present value annuities formula. So if you look at here, it says here financial maths grade 12 present value annuities, and then there's a section where we went through when to use this formula. So let me just wait for this thing to like
not going to do the job, so
skip ad. Thank you. So there's a portion where I think I mentioned where to use this. Let me see here. Yeah, so you see here, I was talking about when to use this formula. Loan, bond, and then here regular payments. So basically the keywords you need to look out for. So the keywords here was like a loan, a bond, a regular payment, and then a repayment of a debt. And then here you see the last bullet point. How long will money be enough to provide regular income? You see, questions like that. You see, how long will this money be enough to provide regular income? Cases like that, you're definitely going to use the P formula, which is like a scenario like this one. You see, they're talking about her having money here. You see, this money, they said she reinvested this money, so it's going to be sitting there gaining interest of like 10% per annum. And then it says here, if she draws an amount of 30,000 per month from this investment, how long or how many full months will she be able to receive this 30,000? So this 30,000 literally represents a regular income to her, you see, because it's basically like money that she is getting from her investment. So a scenario like this, you're going to use the P formula to help you answer it. The reason why you're going to use the P formula to help you answer this question is that the analogy behind a question like this is that you want to think of this as almost like a loan, right? You can almost think of this as like a loan to herself. And then this loan to herself gains interest of like 10% per annum. But then over the months, she is like withdrawing from that money. You see, that money that is like accumulating in value, it's like getting less and less and less and less and less because she's like taking money every month, you see. So that same scenario, it's almost like when a person takes out a loan and the loan is like growing at this rate, and then that loan is like being paid off at this rate. You see, that's the analogy here in this question. And that is why we are using the P formula instead of like the F formula or something like that. Because remember, the F formula is for a scenario where the money is growing and you're constantly adding to it. Here, the money is growing, but then you're constantly reducing it. You see, just like how a loan works. The money grows, but then at the same time, you are paying it off. So eventually, it just goes down to zero. But anyways, in this case, we said we're going to use the P formula. P is equal to x, and then here 1 minus 1 plus I to the power of negative n, and then here the whole thing over I. Now we know we need to get months, so meaning we have to make n the subject of the formula, of which making n the subject of the formula is definitely something that is showcased within, like, you see, the financial maths playlist. Because if you look at it, you see this tutorial here is literally how long. It's like, how many minutes is this? Let me see here. It's how long? It's like 2 minutes something, you see, because it's just showcasing how to isolate n, of which isolating n is important. You see, isolating n is like super duper important, and we're just going to showcase it right now in case you have not gone through that tutorial. So isolating n, you just have to like multiply by I on both sides. So here you have to multiply by I on the left, multiply by I on the right. You're going to have pi is equal to x, and then 1 minus 1 plus I to the power of negative n. So here, because we're trying to make n the subject of the formula, you can divide x on both sides here. So you're going to have pi over x, and then 1 minus 1 plus I to the power of negative n, like that. And then obviously here, this, you can take it over to the other side. Or normally what I like to do here is, this thing here, you see, it has a negative. This whole thing is together. See, this is like one thing, you see. So this is a negative, so I prefer to like take it over to the left so that it becomes a positive value. And then this thing here, because I'm trying to isolate n, it makes better sense for us to move this over to the other side where the 1 is. So here you're going to have negative pi with x at the bottom. And then now we can isolate n, you see, because remember, n is the exponent, you see. So you isolate n, and then we know that isolating n, it's a matter of making the base of the exponent the base of the log as well. So this base here of this exponent is just the base of your log. And then your value here is still just the 1 plus p times I, the whole thing over x. So this is like essential for you to be able to do, because with your financial math questions, they require you not to like round off before your final answer. So the best way to not round off before your final answer is to just make sure that you put the stuff into your calculator all at once and then just get a value, you see. So let me just make this here, create some space. Come on now, there we go. So here obviously we can get a value for n like this, and then just multiply by a negative so that this is like, you know, gone. Whew, so much information, so much information. So here we know that p is just the the $1 million money, what? $1 million money, what are you saying? This is what P is. You see, we can pretend this is like a loan that she has given to herself. Ballers, man, ballers. Okay, but it's not that much. Okay, but let me not hate. Let me not hate for now. No, not at all. Let's see. So this is a lot of money. Yeah, let's not act like it's not. It's good money, this, but you see, you can't buy an M5 with this, so that's why I was like, it's really not that much. But anyways, now you know why I was saying what I was saying. So interest, what is interest? The interest is like 10% per annum, compounded monthly. So it's like 10% over 12. And then N is what we're looking for. X is 30,000. You see, because this 30,000, it's almost like a monthly installment to pay off this money, but it's like a monthly installment to spend this money in this case. But the analogy is the same. So here, negative N is equal to log 1 plus 10% over 12. And then here, 1 minus might as well paste again. The benefits of no pen and paper. You can just paste, copy, paste. Must be nice. So here 10% over 12. That doesn't look very nice, eh? Doesn't look very nice at all. Might as well zoom in and write it better. Like, bro, come on. Come on, man. Come on. You can do better, man. You can do better. So this is like 10% over 12. Much, much better. The whole thing there is over the 30,000. So obviously the way you put this in your calculator is like important. So here your negative N is going to give you a negative value as expected. I mean, like, you know, the negative N value that we're getting here is negative 75.4. And then here you obviously need to divide by negative on both sides. N is going to be equal to 75.4. So obviously this is going to say that if this was a loan, it would have taken her 75 point something months to like pay off the loan. Technically, it would have taken her 76 months to like pay off the loan. But then in this case, it's her spending money. They just said how many full months will she be able to like receive 30,000. So obviously, this implies that she can only receive 30,000 rands 75 times. You see, so here we can say therefore, the question, let's see what is how many times, how many full months. So it's here, let's say therefore 75 full 75 full months. That's the answer here. Fantastic. Nothing crazy, nothing major. Well, let us move on to the next question. For 4 marks here, it also says, after withdrawing 30,000 for 20 months, Buhle requires 1,500,000 rand. Ouch! Somebody wants to ball out. Somebody wants to ball out. Maybe she wants to buy a house somewhere that she can like rent out and get more money. You know, smart people, these ones. It says here, determine whether she can access this amount of money from this annuity. So us determining whether she can access this amount of money, it's almost like a scenario where you can almost think to yourself, imagine the money here is a loan, and we are basically asked to work out the balance on the loan after 20 months here. That's the analogy, you see. I'm basically trying to say that's the way you should be thinking. Don't think too literally. Obviously, it's not a loan, and obviously it's a money, yes. But then the way the scenarios play out, they are very similar to a loan, you see. She's spending money, but then that money is also growing at the same time. It's just like when you pay off a loan. You will be decreasing the value of the loan, but then you're decreasing the loan by paying it off, right? But then the loan gains interest every month. You see, that's the idea here. The 1,600,000 and something gains interest every month, but then at the same time, she is like reducing it by paying off, by using 30,000 every month. So in this case, we just have to find out what is the balance on her investment after 20 months. You see, it's almost like a balance on the loan. So here, let's say here, analogy of balance on a loan. That's the analogy that we use for this question. The analogy that we use is the analogy of a balance on a loan. So when we get the balance on a loan, there are two formulas. You can just use the normal P formula, balance. The normal P formula, if you're going to use it to get the balance on a loan, you have to make sure that your value of N is the amount of payments that are left. And this is what I mean. You see, this here will always be payments left, not the payments that have been made. And then this thing here will be over I. This is one formula for balance on a loan. The other one is if you say A minus F. But anyways, the balance, so technically the amount of payments left. So technically we know that for her to have spent this entire money, we know technically, well, I mean, for her to have spent it all completely, I mean, in our case, we don't want to think in terms of 36, in terms of like 76 months. You see, just think of how she can only make 75 full withdrawals of like 30,000. So here, the total payments, it's like 75, right? Minus 20. So the payments that would have been left would just be like a 55. So here X is like 30,000. And then our interest, we know it is just 10%. So it is just 10% over 12. And then our value of N here is just 55. And then the whole bottom here, you're going to put the 10% over 12, like that. So let's see what this balance is in our calculator. So in our calculator, the balance on her loan is just 1,319,000. Let me just write the 3 a bit better over here. 1,319,260. If you round it up to 2 decimal places, it's like 0.60. And then here we can then say, therefore, no, she can't. She can't, or she's gonna need to, yeah, she can't. Because this amount is like the balance that's in her account. You see, we say it here, analogy of balance on a loan, you see. So that's important to like go through these question papers, because you see, they help you to bump into different scenarios of how they ask these kinds of questions. But anyways, let us move on to question number 8 within this paper. Beloved first principles. Okay, well, I mean, first principles questions, there's really no excuse to not get these answers, like, you know. So normally what I like to do is, if they ask you to work out something, use the first principles. Just work it out using the power rule first, just so that you can see what kind of an answer you should get. You see, like here, if I use the power rule, already I know that this is the answer I should get. So when we're done, we should just compare our final answer to this to see if it is correct. So first principles, they say that we should determine the first derivative from first principles. So anytime they ask that, right, it just means you have to write down your first principles formula first. And this formula, you will get it directly from the formula sheet. So if you write it out, let us see here, yada 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 to the power over h. So having to have written this out, if you're going to solve anything using first principles, or determine the first derivative using first principles, the one thing I always say is try and get this first and then throw it into your expression later. You see, look, getting this just means wherever x is, you're going to have to put the x plus h, and then you can just simplify. So let's put here x plus h, and then see what it gives us. So I have to put a square here. I had forgotten. Oopsie. Yammer. So here, simplifying this, let us see what we are get. There's a 2 here. There's x plus h, and then it's like 6x plus 6h. And then obviously here we have to be careful because the 2 is outside, you see. But then here, if you mix it out here, it's going to be x squared plus 2xh plus h squared, like that. And then let us multiply the 2 inside now. 2x squared plus 2xh plus h squared plus, hey, what's going on? No, big mistake. What are you doing? The 2 is going to be a 4 here, and then this is going to be this over here, and then plus 6x plus 6h. So the reason for doing this is it helps you to not do too many things all at once here, you see, because you really don't want to do that. You see, you really don't want to do that. So here you can now see your first derivative. It is clearly just equal to lim. This whole thing here is just this thing over there, you see. So you can just take this whole thing here. Obviously in the exam you don't have the liberty of copying and pasting, but you just do it manually, you know, just like manual. Yeah, never mind, just do it manually. You see, you've thrown this over there, and the issue is you're subtracting f of x. You see, you're subtracting f of x. So if you're going to minus f of x, it means that this you're going to plus, and then this you're going to minus. Or rather, let me just put in brackets, you see, minus 2x squared plus 6x, like that. The bottom part, we know it is just h, you see. There's nothing much going on at the bottom. It's just an h. Now, the issue is, obviously, if you're going to multiply inside this bracket, if you multiply in there and you multiply in there, it means that these come out as negatives. You see? So to save time and whatever, you can always just make sure that whatever values for f of x that you're dealing with, you should or just write them as the opposite. But hey, on my side, for the sake of explanation, for the sake of explaining, you see, you're just gonna multiply inside. The moment you multiply inside, this is gonna come out as a plus, and then this is gonna come out as a negative. You see, that is super duper important. The reason why that is super duper important is because things always have to cancel out. This cancels that, this cancels that. If you see that stuff is not canceling out, trust me, you have made a mistake, because that's just how it is, you know. Unfortunately, you will have to like check your answers. I forgot the h goes to 0 part here. H goes to 0. H goes to 0. Yeah, to be honest, even though first principles is like 3 marks, it's just so boring, you know. It's like so boring, you know. It is like no character, this one. These questions, they have no character. But anyways, this is like 4xh plus 2h squared, and then plus a 6h over there. The bottom part here is like h. Now, obviously here, you can just take out h as a common factor here, because this is just like with what you call with first principles, it's just such a routine work that you'll be doing. It's like, yo, ooh, yeah. But it is fine, you know. It's 3 marks in an exam, so these are the kinds of questions that everyone loves to like. I feel like I made a mistake somewhere. Like, I really do, I really do feel like I made a mistake. I didn't. Because the h at the bottom is not going to get cancelled now. You see, this cancels that, you see. The only time you should be cancelling stuff is in mathematics. Don't cancel people on the internet. It's rude. Unless they really did say something that deserves, you know, the whole whatever. But I guess you get what I mean. Anyways, simplifying here, you can now throw a 0. Oh, no, I made a mistake. You see how I know I made a mistake? Because I know this has to come out as a negative. And here I'm looking, and it doesn't look like it's coming out as a negative. So I know I did something wrong, which is here, right at the top. It's supposed to be a negative. I think you spotted it, obviously. But for me, it took a while here. So this would be a negative. Oh, no. Wow. Yo, I was literally on autopilot. Yo, nah. That's why even the cancelling, I was just doing it because I knew that was supposed to happen. Wow, this is going to be interesting. So this would be a negative. This would be a negative. And then this would be a negative. Yeah, this is quite interesting, yeah. I think this highlights that with with first principles, yeah, it's just such routine work that you don't even notice a mistake. Like even me, this negative here, it's like my brain knew this had to be cancelled out. I didn't even think of it. But oh well, here we are. I think it also highlights how important it also is to like maybe write down your answer first, so that you know that when you're about to finish off, you can spot if something looks a bit fishy. Like here, the fishy issue was that this is supposed to be a -4 at the end of the day. So yeah, man, I am not happy about making mistakes, but when they happen, they kind of highlight the importance of paying attention. So anyways, it is what it is. So here, carrying on, right, you're going to throw a 0 where h is now. So here you're going to have your first derivative as -4x plus 6. That's the way. I like it. Let me just highlight. Your goodness, I don't even know where I heard that song from, and I haven't done my research because I know for sure that song came from somewhere, but I really just don't remember where. So we threw h as 0 there. That is how we ended up with this. Moving on to question number 8.2. What does 8.2 say? They want us to differentiate. They said get dy over dx. They said evaluate. They said dy over dx is what if this is your given expression. So this question is quite simple. It really doesn't look like it requires any special attention. So here, 2 times 2 is like 4. And then removing 1 from there is like a 1. 4 times a half, that's like 2. Removing 1 from there is a 3. There's your first derivative. This one is quite easy. Like, these people can be generous sometimes, if they really want to. But for 4 marks now, we have to exercise something important. And again, I mean, these kinds of questions, they're definitely, they're there on the course platform, because why not? Why not? No, I'm saying. So here, the idea with this kind of a question is you definitely do want to simplify first. So simplifying first, likely you can see that the top you can just factorize by taking out x as a common factor. So the lucky thing is the bracket that you have left here, it looks as though you can also factorize that as well. Because I mean, the trend here is that the bottom part, you just need to eventually cancel it out using the stuff at the top. So this here, without even thinking about it, I already know that one of the brackets here, if I factorize this, I already know that one of the brackets is going to be x minus 4. The reason I already know that bro, catch your breath. No, you what? Catch your breath and speak nicely. The reason I already know that this is going to be cancelled is because there's a bottom part that looks like it. You see, it's just a trend, Follow the trends. So this factorized, one of the brackets is definitely x minus 4, because factors of 4 that give us a 5, it is a 4 and a 1, you see. And because there's a minus 5 over here, for you to get a minus 5, it technically has to be minus 4 minus 1. You see, minus 4 minus 1 gives you a -5. And then minus 4 times -1 gives you a +4. So that's this factorized, you see. Now let's just cancel these brackets. So this bracket cancels this bracket, and then now you see here, you haven't even thought about differentiating yet, because the differentiating part, that's like the end goal. You see, the mini goal is to simplify. So obviously, getting the first derivative, you may want to just FOIL this out or multiply out here. It's not foiling, but it is what it is. Just multiply in here and then just now get the first derivative. You see, 2x minus 1. Whew, I feel like I'm blazing through these questions now, because we got to do what it is that we got to do. So moving on from here, we have a question 8.3. It's talking about a tangent to a curve. So equations of a tangent to a curve, yeah, those kinds of questions, they're just generic, it's just standard stuff. Here it says a tangent to a curve of y is equal to this is drawn at this point. And then it says here, a straight line parallel to the tangent passing through the y-intercept of the curve is drawn. Just reading this question like this, it's just a bit annoying, you know. There's an equation. They said here the tangent to the curve of this is drawn at this point. Okay, so this is the point of intersection. You see, point of intersection. And then it says a straight line parallel to the tangent passing through the y-intercept of the curve is drawn. And then they said here, determine the equation of the straight line. Wow. Yeah, this kind of a question, I think drawing images is going to help you. Otherwise, yeah. So this is clearly a smiling parabola where the y-intercept is like a negative 5, you see. So let's just draw a negative 5 over there. No, bro. Negative 5 is down here, man. Negative 5. So if it's smiling, then this graph has no choice but to look like this. They said the point of contact is where x is a 2 and y is like a negative 3. So that's like somewhere here. Now, don't take for granted the fact that you're seeing that this tangent is going to have a positive gradient. You see, that's like information that your sketch is giving you. So don't take it for granted. So yeah, there's a curve here, and it says a tangent to the curve is drawn at this point. A straight line parallel to the tangent through the y-intercept of the curve. So the straight line that they're talking about, right? They said it passes through the y-intercept, right? And it is parallel to the tangent. So this is the green one here. Like that. So the equation of the green one is the one that they want us to get. You see, here they taught us all this, then they say determine the equation of the straight line. So luckily, we can just get the equation of the tangent to a curve first, and then use that to get the green one. Because for the green one, we already know that y is equal to mx minus 5, you see. We already know that. So we just need the gradient of the straight line by, we can get the gradient of this green line by getting the gradient of the tangent. So to get the gradient of the tangent, we can just use the curve, you see, because a tangent and a curve share the same gradient. So dy over dx gives us the gradient equation because what? Because why? Well, yeah, the first derivative is always just the gradient equation. So the gradient of the tangent is going to be the gradient of the curve at this specific point over there. So let's see, dy over dx here is just 4x and then minus 3. So if you're going to throw, if you're going to find gradient at the point of intersection, you need to throw a value of 2 where x is. So here, let's see here, if you're going to throw 2 in here, you're going to get a gradient of positive 5. You see, that's just a coincidence. You see, that's the gradient here. It's just a positive 5. So here we can say that the equation of the straight line is just y is equal to 5x minus 5, you see, because as soon as we get the gradient of the tangent, it automatically gives us the gradient of the straight line that they are talking about. You see, nothing crazy here. We need to just be able to interpret these kinds of questions. So let's move on to question number 9. Okay, question number 9. Let us dive right into it. Whew. Determine the points of the curve of this. I think it's supposed to say where here. Let me just fix it. Let me fisk it quickly. Fisk it. There we go. Determine the points on the curve. This is clearly a hyperbola. It's a hyperbola because x is like it's like the denominator. So here they say determine the points on the curve of this where the gradient of the tangent to the curve is like a -1. Oh wow, and it's a whole 5-mark question. Wow, you can really dance. This is interesting. So this is a curve, right? y is equal to 4 over x. Determine the points on the curve where the gradient of the tangent to the curve is a -1. Okay, that's not so bad. So we're talking about gradient being a -1. So what you can do is to get the gradient expression. So here, before you can get gradient, you have to simplify. Simplifying this can go up first. You're going to have 4 with x to the power of -1. So dy over dx gives you the gradient equation. It's going to be like -4x to the power of -2. Now you want to work out the points where the gradient is a -1. So what you can do is you want to find out the x value where the gradient is a -1 first. You see, so where gradient is, you're going to throw a -1 over there, and then you're just going to solve for x. Solving for x here, it doesn't look like it's going to be anything crazy, but it does look as though you may need to divide both sides by a -4 first. You're going to have 1 over 4 equal to x to the power of -2. But then obviously if you're dealing with a negative exponent, it's best to put it down there. And then from here, if you want, you can just cross multiply. You're going to have 4 times 1 over there. This times that over there. You're going to have x squared is equal to 4. And then x is equal to plus or minus 2 if you square root of both sides. So we have 2x values. Wait, no, let me do this. Square root here, square root here. So we have 2x values, right, where the gradient is a -1. But then they say the points, you see. So meaning here you have to give coordinates, you see. That's why this is a 5-mark question. Coordinates. So just the x values won't do. You need to get the y values as well. Of which, to get the y values, clearly we can just say here y is equal to 4 over -2, which is like y is equal to -2. Or y is equal to 4 over 2, which is y is equal to 2. So obviously as coordinates we can then say, therefore, if the x value is a -2, y is also a -2. And then here, if the x value is like a 2, y is also a 2. There we go. So this is like point number 1. Point number 2. They will give you 5 marks for that. So this kind of a question, yeah, it's kind of strange. It's kind of odd. You may be asking yourself, why are they asking such a weird question? Well, they just did, you know. They just did, and we just answered it because why not? You know, why not? But anyways, the next question out of 2, it's a new question with a new diagram and everything. It says the graph what? Just make this a bit bigger, get myself ready. The graph of the cubic function with this equation has been drawn below. So here they've told us that if you throw in x as 1, your y value is a 0. If you throw in x as 4, your y value is also a 0. So these are just intercepts, because if x is a 0, it's an intercept. You see, these are x-intercepts. Let's just put here x-intercepts. X-intercepts. So that's why this is like a 1 and this is like a 4. Secondly, they said here f has a local maximum at point B and a local minimum at point where x is a 4. For 2 marks, they said show that A is this, B is this, C is this. For 2 marks only. Oh my goodness, these guys are so mean. Oh well, I think they're trying to imply that this is one of those things that you just need to know from the back of your head, in the sense that what they're trying to do here, what you're trying to keep in mind is, with any cubic function, you have to remember that when it is factorized, it's always in the form A with like x minus x1, and then x minus a second x-intercept, and then x minus a third x-intercept. The only issue is that as long as your graph turns where it has an x-intercept, these two will be equal to each other. You see, this is specifically for this kind of a scenario. And for this kind of a scenario, these two that repeat will be this 4 over there. You see, so this simplified, let me actually put a k here because we already have a somewhere. You see, this k in front there is literally just the value that goes over there. That's what your k value will be. You see, so we already know that is just a 1. So here we know that this will be equal to 1x. Here we have a positive 1 over there, so this has to be like a negative 1. And then you're going to have x minus 4 here, x minus 4 over there. And then if you simplify, you're going to have x minus 1, x minus 4 squared. You see, like that. And then here you can just simplify, just break it down. Anyways, x times x would have been like x squared. X times a negative 4 would have been a negative 4x. And then another negative 4x would have given you negative 8x in the middle. And then here plus 16. Let's just multiply this entire bracket out. X and that is like x cubed. This and that is like negative 8x squared. This and that is like, no, this and the 16 is like 16x. And then negative 1 times negative x squared. And then negative 1 plus the 8x. And then negative 1 multiplied by the negative 16. There we go. So obviously we might as well just simplify everything now. You see, this is like x to the power of 3. This and that is going to give you 9x squared. And then clearly that's going to give you a 24x and then a negative 16. Whew, but I do wish that they could have given us some more marks, you know. Yeah, because that's just some rude meanness right here. 2 marks only. That's some disrespect right there. Some disrespect, man. So this will be worth 2 marks. You can even leave it like this. You will be 100% okay. Moving on. For 4 marks now, they want us to get B. B is the turning point. And we all know that when you get turning points, you just differentiate and equate to 0. That's like a no-brainer, you know. Okay, it's not like, okay, it is, because you should know that, you know, because it's the important 3 mark stuff. So getting the turning points, you always get the first derivative and you equate it to 0. You see, that's how you get the x values of the turning points. And then those x values, you then come back and you throw them over there. You see, so in our case, we're going to get 2 x values. One is going to be a 4. The other one is going to be the one for B. So let's do it. Let's do it. dy over dx here, it is just 3x squared minus 18x plus 24. Fantastic. And then we're going to make this a 0. This is like 3x squared minus 18x plus 24. So here, let us make, we're going to need to solve for x, you see. We can just do that using the quadratic formula. Minus b plus the minus b squared. Where is b squared? We've got the b squared. Where is b squared? I'm acting like an idiot here. Like, really, bro? Come on now. Come on now. So here, plus or minus b squared minus 4. A is like a 3. C is a 24. And then the whole thing over, what is this now? Over 2a. There we go. So here, our answers come out as x is equal to positive 2 or x is equal to positive 4. You see, those are the x values. So to get the corresponding y values, you just throw them back into your equation here. You see, if you throw them back into your equation here, you're going to get y is equal to 4 or y is equal to 0. You see, that's if you throw them back into the original equation. You see, wherever x is, you would need to throw a positive 2 there. You get an answer, and then for the other one, you're also going to get an answer. So let me color code them. For the 0, this one, you get it after you have subbed in F4. Do that. Hey, what's going on? Change color. There we go. And then for the green, it's after you've subbed in a 2, you see. There you go. There you go. So let me say here, sub in y. No, sub in x values. X values, dot, 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 you see. and then you'll be good to or go. Nothing crazy about that question really. But then the thing is, they said we should get B. So B is obviously the one where the x value is like smaller than 4, you see. So therefore B here, we can then say, therefore B, it's the one where the x value is a 2. And then if the x value is a 2, we can see that the y value is just a 4 over there. Voila. Moving on, he says he determined the values of k for which this has only negative roots. So the idea with a question like that is you need to know how to interpret questions that talk about roots. I mean, we already stated that roots are just x-intercepts of your graph. So let me just trace this image here so that I can use it. To answer the question, you know. See here. There we go. So let us do what can happen here. Let's do this. Let me, hey, what's going on now? Oopsie, that's the way. I like it. Let's see here. Yeah, so to answer this question, using a sketch is the best way to do it, because sketches make the world go round, you know. Sketches make the world go round. So the image, the way it looks, so far this image has 2 roots, you know, because roots, remember, they refer to like x-intercepts. There's like an x-intercept there, another x-intercept. They said for 2 marks, for which values of k will your equation have only negative roots. Wow, that's quite interesting. Like, that's like really interesting. Like, it's not even funny, eh? It's like not even funny. But then the key thing is, this kind of a question, this is the kind of a question where you see that the course platform is necessary, because in the course platform there's like a bunch of questions where it's freaky like this. So if you think of it nicely, for this to have negative roots only, it all depends on things like where the y-intercept of this graph is. Let me just try and draw this graph a bit differently, so that the explanation I'm trying to so that whatever I'm trying to explain is a bit more clearer. So if you look at this graph, at some point here, this graph has like a y-intercept, right? This y-intercept is like -16. We know that because of the way our equation is like weighted out. You see, this is the equation, this will always be the y-intercept. So for this graph to have negative roots, this image has to be moved up 16 units for it to start having negative roots only. So this is what I mean. Let me take this image here, copy it, and show you the magic. Copy this thing here, paste it over here. So this is what it looks like now, right? But then if you look at the graph here, the way it is so far, it has roots that are positive. You see, the x-intercepts, they are positive numbers. So for you to have x-intercepts that are negative, or for you to have an x-intercept that is a negative, you're going to need to move your graph at least 16 units upwards. Because if you move it 16 units upwards, right, this is where it's going to be. It's going to have a root that is equal to 0. But then the moment you move it more than 16 units upwards, you can already see your graph is going to start to have y-intercepts, or rather your graph is going to start to have x-intercepts that are negatives there. You see, that's the idea behind this question over here. You see, your graph needs to be moved up at least 16 units for it to have negative roots only, you see. So this value of k here, if you think of it, when you bring k over to the other side, because technically here you want to think to yourself, you have, what do you have here? You have the equation of the graph, right? Where's the equation of the graph? This is the equation of the graph. Let me say copy here. Let me say paste here. Paste. So if you look at your f of x, right? Let me just write this like this nicely. Let me also change this to f of x so that you know it is a, so that it is presentable. So this is f of x over here. So this scenario here, for you to find out what you're going to say, like, are you going to say k is bigger than 16 or k is smaller than 16? What you do is the k goes over, right? So you're going to have a scenario like this. There's k of x here minus k equal to 0. So in our case here, we would have our k here as a minus. So you see here, f of x minus k is the same as this equation here, minus k. So we know that a number here has the same effect as moving the graph downwards. You see, a positive number here moves the graph downwards, but then a negative number here moves the graph upwards. Because if you put a negative number here, that negative number is going to be multiplied by a negative number. So a negative and a negative give you a plus. So a negative number here has the same effect as moving the graph upwards. So in our case, if we want to move the graph upwards, right, we're going to need to say that k has to be smaller than negative 16. The reason why k has to be smaller than negative 16 is because if k is equal to negative 16, it means that you would have moved your graph 16 units upwards, you see. But then the moment it is anything that is smaller than 16, like let's say negative 17, if you throw a negative 17 over there, it will be negative 17 times a negative, which will be a plus. Meaning here you would have plus 17, you see. And you adding 17 here means you would have moved the graph 17 units upwards, you see. So that's why here you have to say k is smaller than negative 16, because a negative and a negative is what is going to cause your graph to actually move upwards for it to eventually have only negative roots. Because at this point in time, you see, it has one root that is a positive, one root that is equal to 0. But the moment it goes beyond this image here, it is going to it's going to be having negative x intercepts only. But it's a 2-mark question, and again, these kinds of questions, they are definitely there in the functions and graphs course. Like the functions and graphs course is one of like the heaviest courses on the course platform, because yeah, it just goes down. It goes down so hard in that course. But anyways, it is what it is. 9.2.4 here for 2 marks says determine the values of x for which f of x is concaved up. So I mean, concavity all depends on where the asymptote, all depends on where the point of inflection is. So we can even use this image to help us, you see. So our point of inflection, let me actually just paste that image here. No man, not that. I want the graph. Ish. Let me not even complicate concavity. So the easiest way to get where a graph is like concaved up, right? Just work out where your second derivative is bigger than 0. You see, just work out where your second derivative is bigger than 0. That's how you work out where the graph is concaved up. So the second derivative, let's see what the second derivative is. So to get the second derivative, we can just start from here, you see. Differentiating your first derivative, you're going to have, let's see here. You're going to have 6x, and then minus 18. So you're working out where this is concaved up. You're just going to work out where this thing here is bigger than 0. So let's see here. Where is this thing here bigger than 0? So the 18 goes over. You're going to have 6x bigger than 18. And then you're going to divide both sides by a 6. You're going to have x's bigger than a 3. Which is fine, you see. So the 3 here is definitely our point of inflection. And we can see that everywhere from 3 going upwards, like everywhere from where x is a 3 going to the right, that's the part of the graph that's like smiling. You see, that's the part of the graph that is concaved up. You see, that's just for knowledge, for wisdom. But anyways, that is that for question number 9. You can always hit me up if you want clarity on anything, and then I will respond. You know, I respond to all my DMs, like legit. Might as well let me what am I gonna do here? What am I gonna do? Like legit, I respond to all my DMs. Like legit. You see, like if someone asks me a question, like here you see most of these people here, most of these here, oh, this is just like embarrassing. It's really not. Most of these questions here, they're like math questions. You see, if I click on this one here, it's a random DM. It's a math question. If I scroll down and click on like another random DM, let me see here, like this one, you see, this is obviously a math question as well, you see. So you can always DM me questions, but just make sure that if you're going to send a DM, you have like gone through the question, you have done your part and all that shandies. Otherwise, it's like, manje. It's all good. Let's move on to the next question. Whew. The good news is that this is the second last question. Like, would you believe it, huh? We have made progress, we have made progress. But now we have like an applications of calculus question. So we have to be careful, We have to be careful. So let us be careful. Let's see what they said here. It says the diagram below represents the graph of y is equal to x squared. So it's a basic parabola, thank goodness. And then it says here it has a rectangle. It's a basic parabola and rectangle PQRS. So let's see here, PQRS. Fantastic. And then they said here the point P is a common point on both the graph and the rectangle. So where is point P? Let's do this here. Point P is a common point, yes. And then it says here the graphs of x is equal to 6 and y is equal to 0. So you have the graph x is equal to 6 is a straight line going downwards, you see. This is the graph x is equal to 6 and the graph y is equal to 0 represent two adjacent infinite lines of rectangle PQRS. Why are these guys trying to be so extra now? Like legit though. Like what infinite this, infinite that. Come on, man. Come on. No, man. No. But anyways, let's see here. The line x is equal to 6 is this one. You see, x is equal to 6. The line y is equal to 0 is this one. You see. And then they said here those two represent two adjacent infinite lines of rectangle PQRS. Don't panic with that kind of a phrase. It's just like it's just, I don't know. They've just told us stuff that we can see, really. There's really nothing much to what they've said, but at the same time, it's important. And then they said here the coordinates of point R, which is that here, and point Q, which is this over here, are given. You see, so they're basically telling you that whatever Q is, it is the x value of Q, right, is obviously going to be 6 minus x, of which technically that just means that the distance between Q and R is always x, you see, because 6, which is the whole thing here, minus x is what's going to give you the x value of Q. So do not forget that. Okay, all this being given, for 1 mark they said write down the coordinates of P in terms of x. So P in terms of x, the good news is, remember where P is, it's a point on the parabola. So use that to your advantage, you see. So it means that y is equal to, the equation of the parabola is that y is equal to x squared, you see. Y is equal to x squared. So y is equal to x squared is obviously the equation of your parabola. So the coordinate of P here, we know that the x value is just 6 minus x. The y value we don't know, you see, but we can get it from our equation over there. You see, we can just throw the x value into our equation and then we're good to go, because remember the x value of Q is the x value of P as well. So here y is equal to, wherever x is, we can throw the coordinate of Q, which is this value here, squared. And then, yeah, this we might as well not simplify it. Just leave it like that. Otherwise, you're just going to create a mess for yourself. So here's 6 minus that, and then here it's just 6 minus that squared. There we go. That's why this is just a 1 mark question. So at least here, even if the rest of the questions are like super crazy, at least here you get some marks, you know. Whew, let's see how many marks this next question is out of 5. Determine the maximum area of the rectangle. So the one thing I can safely say is, what you'll hear me say in like the applications of calculus course is that anytime you get questions like these where they're asking for the maximum of something, always think to yourself, okay, what kind of a formula do I have? I need to deal with an area formula here for a rectangle, you see, of which the area of a rectangle is just length times breadth, you know. We need an area which is just length times breadth. But then this area that we're going to get, we obviously need an expression for the length, we need an expression for the base, which is quite simple because the y value of p gives us the length, and then the distance between QR gives us the breadth. You see, like it's just that simple. Like here, if you draw your shape, there's P, Q, and then there's R and S. You see, some of these questions, they will just be extra for nothing, like legit. It's like, you see, what are you trying to do? Are you trying to be scary or what? Like here we have identified that this is X. We have identified that this is 6 minus X squared. And then this is the length of the area here. It's already in terms of X, you see. So if you're going to determine the maximum area, what you need to do is you need to get an area equation first based on the information that you have. So here we can say length is just X, the breadth is just 6 minus X squared. So this is the area formula. So for us to get the maximum area, we need a value of X that causes the maximum area. So for us to get a specific value of X here, we need to take our area formula and then we need to like simplify it first and then differentiate it and then equate it to 0. So let me say this slowly. Our area formula, we need to differentiate it and equate it to 0 so that we find an X value that we can throw here for us to get the maximum area that they're looking for, you see, because this maximum area, clearly, I mean, like you have an area formula already. So you just need to get a specific X value that will give us the highest possible area. So here, simplifying before differentiating, we know that it's just going to be 6 minus X here, 6 minus X here. This is just X. Let's see what we got here. This is like 6 times 6 is like 36. 6 times that is like negative 6x. And then another negative 6x and then x squared over there. And then what? And then what? This is just like x outside. This is like 36. What's this now? Negative 12x plus x squared. And then this is just like 36x minus 12x squared plus that. Whew, is going down. So this is the area formula now, you see. And this area formula, you can now differentiate it because it's in a format that can be differentiated. So differentiating this, I just need to be careful that I did not make like the silly mistake or anything like that. Otherwise, that's just sad, you know, like silly mistakes, they're so depressing. Just so depressing. But anyways, everything looks fine. Differentiating this, it doesn't have to be in standard form or whatever. As long as everything can be differentiated using the power rule, then you're good to go. So 1 times the 36 here gives you 36. And then here you're going to have 24x. Then here you're going to have 3x squared. So we said you differentiate and you equate to 0. Hey, might as well write it in a nicer looking format here. Otherwise, we're gonna not have smiling faces here. 24x plus 36. So the big idea here is obviously you just want to use your quadratic formula. Minus b plus the minus b squared. Yep. B squared minus 4a and then c over there. So all this, we're just going to put into our calculator and then we're going to get an x value. Oh, why is this thing doing what it's doing. So solving for x here, you're gonna have two values, right? This is like over 2a, so it's like 2a. So here you're gonna have x is equal to, let's see in the calculator here, gonna get a 6, or x is equal to a positive 2. So the only issue is, I mean, just judging from our sketch, x cannot be equal to 6, otherwise x will be like all the way there, you see, of which that cannot be the maximum area. I think that, remember, when you're going to differentiate and equate to 0, you always get two answers. One gives you the minimum and then one gives you the maximum. So here, this one clearly is going to be the one that gives us the mean. This one is the one that's going to give us the maximum, you see. So that's why here we have to rule out the 6, because if x is a 6, it just means that this thing here is stretched out all the way until there. So your rectangle will literally just be a straight line here, you see. It won't have any area. So that value of 6 is going to give you the minimum area. So the value of 2 is the one that gives you the maximum area. So because we now know our area will be a maximum where x is a 2, all we have to do is that in the equation for area, we just have to throw in an x value of a 2 there and then get an answer. So here area, how do you spell area now? Area is going to be equal to 2 here with 6 minus 2 squared. That's like a 4, right? 4 squared is like a 16 times 2, that's like 32. So the maximum area, I keep writing A whenever I want to write E. Like, how, man? How? So the area is just equal to 32 there. That's the largest possible area. Nothing crazy. Okay, yeah, this question was not so bad. It was actually kind of straightforward, and you do get questions like these quite often. So it's okay. Let us move on to the last question, which is question number 11. Like, yay. Okay, question number 11. Like, oh my goodness. We are there. We are within. So with a question like this one, the interesting thing with a question like this one is, let's see, it says here A and B, given that A and B are independent events, they've told us that the probability of B only is 0.3. So questions that start off by saying stuff like this, well, obviously if you scan the question, it looks as though you have like two events at the end of the day. Questions that start by saying stuff like this, you say the probability of B only and stuff like that, always try and see if you can draw some kind of a Venn diagram for yourself, because it will help you answer the question better, you know. It will help you break down the question. So even me, let me see here if I can draw a Venn diagram. Zoop. Danko. So this Venn diagram here, clearly we can see that we're going to have two events here. Like, it is so clear, you know. We're going to have event A over here, and then, hey, what's going on there? And then it looks like we're going to have event B over here. Let's do that. Let's make this a bit bigger. Because, I mean, why not? You know, why am I wasting time with this? Anyway, so we have two events, right? Let's label them event A and event B, because we can definitely do that. So let's see here. This is like, let's label this one B. Let's label this one A. So they say here the probability of B only is 0.3. So B only here, we can put a 0.3 over there. And then they said the probability of A and B, it's 0.2. So you can put a 0.2 over there. And then they say the probability of A only is an X. So you can put an X over there. And then they say the probability of not A or B is Y. So this is saying anything that is outside of A and B, you're going to have that as Y, you see. That's the best way to represent this given information. So they say here, determine the values of X and Y. So, I mean, they say the events are independent anyways. So if you're going to determine the values of X and Y, we might as well start off with this formula. For independent events, we know that the probability of A times the probability of B, or rather the probability of A and B, is equal to this multiplied by the other one. Because I think like writing it this way is, you know, something that more people can resonate with. This is the probability of A, and the probability of B. This is like not on your formula sheet, but you need to know it. So in our case, if you're going to solve for x and y, I think we can do x first, probably, because if we use this information, this we have, and what else do we have? This we don't have, but then that we have, you see, because in our if you look at our Venn diagram, right, let's do this down here. If you look at the Venn diagram, there is evidence that we have information. So the probability of A and B, I mean, this one is just 0.2, you see, 0.2 is equal to the probability of A. If you look at your sketch, the probability of A is these two put together, you see, it's just x plus 2 multiplied by the probability of B. The probability of B is just this put together, so it's like 0.5 over there. And then this is like these two multiply. You don't have to, I mean, like, you're trying to solve for x here, so the best thing you can do for yourself first is to just divide by 0.5 on both sides first, you see. So here, gonna divide by 0.5, and then here you're gonna have the x plus 2, and then here the it's 0.2. Sorry, I meant 0.2. I'm sorry. What the hell, bro? Like, what in the world? This is just a 0.2. So when the 0.2 goes over to the other side, you're gonna have here 0 over that minus a 0.2 is equal to x. So here your value of x is just gonna be equal to 0.2. It's just a coincidence that x is also 0.2, but I think the Venn diagram is really helping us here. So for the y, likely with y we can just use the sample space, you see, because everything, when you're dealing with probabilities, everything should give you a 1, you see. So technically your value of y is equal to, is whatever is left from 1 after you've removed all these other probabilities. So what can I do with this arrow here? I need to finesse this arrow so that it is not like that. So this here is that. So for getting the value of y, we can say that y is equal to everything, is equal to 1 minus everything in here. So it's going to be minus 0.3 minus the 0.2 minus the other 0.2 there, which is going to be x. So our y value here is technically going to be 0.3 because this is like 0.7 here. That's x and y, you see, thinking outside the box. You see, questions like these, I mean, you can imagine the course platform. What am I doing here? I want to go to the course platform. Okay, I mean, there's a probability course on the course platform because I mean, like, the entire syllabus is on the course platform anyways, you see. So with the probability course, it's one of the latest ones. It also goes through like the fundamental counting principles. So you can imagine you have like 4 chapters here. You see, a chapter going through general probability, of which in that general probability chapter, you can already see here going from mutually exclusive to independent, and then let's say here find the probability of A or B, yada yada yada. You see, there's a chapter on tree diagrams, there's a chapter on Venn diagrams, a chapter on two-way contingency tables, and a chapter on like the fundamental counting principle. You can see the fundamental counting principle section is like the one that has like a lot of lessons. But this course in total, the probability course, it's like around 3 hours in total, meaning in like 3 days you can be done with probability, or in like just a day or two, you know, depending on your appetite. So yep, I recommend the probability course because that's how you're going to work with stuff like this. You can imagine the Venn diagram chapter here. Like, if you look at the Venn diagram chapter, you see there's like 1, 2, 3, 4, 5, 6, 7 lessons, so they can properly understand the topic. Like here, drawing a Venn diagram from 8 pieces of information, you see, making use of a Venn diagram, sorting odd and even numbers in a Venn diagram, blah blah blah. You see, just a bunch of stuff that you really need to know how to do. For 3 marks here, they said 6 players of a volleyball team stand at random positions in a row before the game begins. So obviously, reading so slow, it's like, ish, what's going on. So this is 6 players. So normally what I like to do is, as I'm reading the question, I like to draw pictures to help me eventually answer the question. Like here, they're talking about 6 players of a volleyball team. They stand at random positions in a row. So you have 6 people. 1, 2, 3, 4, 5, 6. And then they said here, X and Y are 2 players in this team. And then they said here, determine the probability that X and Y will not stand next to each other. So questions like these, you need to be systematic about it. Otherwise, you're going to have a hard time answering them. So if you're going to work out where these people are actually not going to stand next to each other, the one thing you actually need to do is to work out where they will actually be standing next to each other. Meaning, what you have to do is you have to work out all the scenarios where they are standing next to each other, and then you remove that from all possible outcomes where there are no restrictions. So what I mean is, if you're going to get this, it's going to be all outcomes minus ones where they are together. You see, minus outcomes where they are together. You see, that's the only way you're going to get the outcomes where they are not together. You take the ones where there are no restrictions, you minus the ones where they are together. You see, because working out the scenarios where they're together is something that we know to do, and it's something that we can easily do. So the scenario, all the outcomes without any restrictions, we know that it is just a scenario where you're dealing with 6 people. You see, so those 6 people, when they are all standing, you see, there are like 6 options for this slot. You see, the moment you put one in there, there's like 5 options for this one. The moment you put one there, there's like 4 options here, then 3, then 2, and then 1. You see, this is all the possible outcomes. You see, 6 times 5 times 3 times 2 times yada 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 yada. This is just 6 factorial. You see, that's like all the outcomes. That's all the outcomes. The outcomes where they are sitting together. So let's say here, where they are next together. Let's say here together. The ones where they're together, you just have to think of the 6 places again. You see, these 6 places, the ones where these people sit together, all you have to do is to say they're together, right? So you paste them together like that. Now, when they're together like this, you have to remember that these people that are together, they can be arranged in 2 factorial ways. And then in total, you have 1, 2, 3, 4, 5 objects, you see, of which those 5 objects can be arranged in 5 factorial ways, you see. So the cases where they're together, it's just 2 factorial multiplied by 5 factorial. You see, 5 factorial. So obviously the factorial button is like, where is the factorial button? Like there, like bottom left from the on button. So this is just like 240. You see, there we go. Okay, fantastic. So you see here, outcomes where they're together. The outcomes where they are together, we can clearly see this is just like 240. The outcomes where there are no restrictions, it's just 6 factorial. So 6 factorial in our calculator, let's see what that is. It is just 720. You see, all the possible outcomes, it's just 720. Ones where they are together, it is just 240. So in our calculator, we just have to say 720 minus the 240. So let's see what that gives us. This 720 here minus the 240, this is giving us a total of what? What is that giving us now? Let's get into this calculator. 720 minus 220, 240, that's like 800, and that's like 480. So the chances that they are not going to be together, there are 480 ways where that happens. But then if you think of it, the question asked for the probability of that happening. So the probability of that happening is technically going to be 480 out of all the possible outcomes. You see, this is the probability that these people don't sit next to each other, of which this is just 2 over 3. You see, because before you can work out the probability, you obviously need to work out what are the outcomes in the first place, because you can then say the total outcomes over the relevant outcomes over all the possible outcomes. That's going to be your probability. So questions like these, they're either going to highlight whether or not you need to, enroll into the probability course, because obviously you can imagine, like you saw here, this is more like questions on the fundamental counting principle. And as you saw here, the title of this course is actually as you see here, probability and the fundamental counting principle. And as already shown here, the fundamental counting principle is one of the longer topics. You see, the ones where it has like, it's one of the longer chapters. Not to say it's like gang long, but I'm trying to say it's one of the topics or one of the chapters that really go in depth in how to answer these kinds of questions here, you see. So 11.3 says determine how determine how many 4-digit numbers can be formed from 10 digits, which is like from 0 to 9, if repetition is allowed. So this one is quite easy because they're asking for how many 4-digit numbers. So in terms of 4-digit numbers, you have like one slot, another one, and another one. So if you have 10 numbers to choose from, if repetition is allowed, it means that here you have 10 options, here you have 10 options, here you have 10 options, and then here you also have 10 options, you see. So obviously these are all your arrangements. It's 10 to the power 4, which is just, I think, is it 10,000? 100,000? Man. But then the thing is, the issue here is the first digit actually cannot start with a 0. You see, because if it starts with a 0, it makes it like, it's more like a 3-digit number. So here you only have 9 options in the front because you cannot start with a 0. So here it's actually just going to be 9 times 10 to the power of 3, of which your final answer there, this is like 1,000 times 9, that's like 9,000. So I think that was something to take note of. You see, the front here, you cannot start with a 0 because they don't recognize the number starting with a 0 as a valid value anyways in this situation where you are dealing with 4 digits. So look out for cases like that, because those kinds of things, they still marks in exams. So they say repetition is not allowed. So obviously here, same idea, you can have 4 slots. In the front, you automatically know that you only have 9 options, you see. But the moment you put one number here you only also just have 9 options left because one number has been used up, you see. So here you can only choose between 0 and 9 or 0, 1. You can choose between 1 and 9. All the numbers between 1 and 9 are your options here. So you have 9 options. But the moment you throw one number in here, there are only 9 options left because the value that was here, or the value that has been put here, is now used, you see. So you only have 9 options here now. The moment you put one value here, you only have 8 options left here. The moment you throw one number there, you only have 7 options left for the next one, you see. Because they said here repetition is not allowed. So let's see here, 9 times 9 times 8 times 7. That is going to give us 4,536. Fantastic. We are literally at the last question. Oh, this feels so good. You have no idea how this good feels. But I'm sure if you've been following along and we're both here together, then we know we are it's like, it's such a nice moment. It's such a nice moment to know that we are here at the end. It says the last digit, so we have to work out, let's see here, determine how many 4-digit numbers can be formed from 0 to 9 if the last digit must be a 0 and repetition of digits is allowed. Well, these ones are like quite easy actually. So you have 4 positions here. They said the last digit must be a 0. So obviously here you just have one option. They said repetition is allowed. So it means here you can put one of 10 values. And then obviously, they say repetition is allowed. Yeah, they said repetition is allowed. Well, I mean, like, if repetition is allowed, then, I mean, repetition of digits is allowed. The last digit must be a 0, and repetition of digits is allowed. Okay. So here you have 10 options, and then here you technically also have 10 options, but then in the front, remember, your values, your number cannot start with a 0. Your number cannot start with a 0. So here you only have 9 options for the front. So your number of options, let's see here, it is technically just going to be, what is it going to be? It's going to be 9 times 4, 9 times 10 times 10 times 1, which is just going to give you 900 options, you see. So that's that for this one, because they said, remember, they said with repetition. They said here you can repeat your what you call your digits. So if you can repeat your digits, then yeah, you need to make sure that you put a 10 and a 10 and a 9 here, because here only one option is just a 0, but then here you have all 10 options to use. Because they said you can repeat, here you also have all 10 options, and then in the front you cannot put a 0 in the front there, so here you only have 9 options for the front, and then your number of options there, it is just 900. Whew, this felt so good to finish off. But I think, on, like, if you see something fishy on the memo, like some of these printed out memos, like, just call it out, because sometimes you never know. So you can always hit me up on IG if you want to ask something. And as mentioned already, this is the course platform where you can, dive deep and ace those exams. But anyways, this is that. I am like super duper tired right now. I'm assuming you're also tired, so we should go get some rest. And then I'll catch you in the next paper. Oh yeah, don't forget to subscribe, like, yada yada, all that shandies. Don't forget to tell your friends, because I mean, you can imagine, I feel like this is super duper useful and super duper helpful. So be the ultimate plug in the squad. Know what I'm saying?